Um,
Um,
no new
okay, so I think we
file.
should probably be there. Yes, yes, things are up. So how are you doing?
Pretty decent. A little, long day, but that's kind of par for the course these days. So uh, on and on we go.
Yep,
Uh,
yep.
how about
Um,
you?
all right, similarly long day. I actually got up at 4 this morning for reasons that I don't want to get into.
Oof.
But not that I don't want to, but it was just take a little too long.
Right.
But yeah, so I took
Okay.
a brief nap late this afternoon, but I've been
That's
up for a
good.
long time otherwise. So, and it's been a rambunctious day with the kitties. It's funny. They have a chart in my vet's office, like sort of trying to equate cat ages with like people ages, and my cats are the equivalent of 85. I'm going to say I've not seen a lot of 85-year-old ladies go tearing around the house quite the way that little girl does. But so I don't think the chart, like,
You hang out with a lot of 84, 85-year-old ladies in your house. They're like, but they're not tearing around.
they're
Huh?
not tearing
So,
around, right? Yeah, no.
yeah.
It just yeah, she's pretty rambunctious kitty. So there may be some yowling this evening, just
Okay.
because they've been a little bit yowly lately. But anyway,
Can't
so
blame it on having fever. Well, I mean, maybe it's their form. They don't really.
therefore, they are perhaps a little understimulated. So, but yeah, so last week you were not feeling well. We did not stream, which is fine. But I do think that we're probably going to have to re-go over quite a bit of stuff, because I think at this stage in your embryonic journey, probably 2 weeks is a long time. So
Oh, for sure. I mean, I did take a quick peek at the saves, notes from the session, or not even notes, but uh,
the REPL
uh,
log, yeah, yeah, you may want to
yeah.
pull that open. Actually, that would probably be a good idea. We'll take a look and like try to remind ourselves of what we talked about, and I think we'll probably just want to talk about a lot of it again, at least briefly.
Yeah, and
Perhaps not so
unfortunately,
briefly.
uh, maybe this is now. Was this when it was session? I'm missing stuff here, right? Are you seeing? Let me see here.
I see a racket file that has
There we
sort of
go.
the top stuff in it, but there was also a file with
Here we go. This is the one I was looking for.
okay,
I never went back and like
okay.
cleaned
There's
it up or anything. This,
really significant lag here. But okay, I can see
yeah,
it now. Yeah, it mostly happens anytime a lot of pixels on your monitor change, we get like super serious lag. But that's okay. So you may want to like, can you open to? Is it possible to? Yeah, well, okay, you could do that. The thing about it is we probably want to be able to type some stuff and look at this at the same time,
gotcha.
like in a different REPL. So can you open
Not
maybe
letting
another
me.
window?
Um,
Okay. Do you know how to like unmaximize stuff? There you go.
yeah,
There you go.
that's what I got now. Um,
Okay. So
let's see.
can you tear that tab off? Are those terrible? Are they
I
undockable?
think so, but
So that you have
maybe not.
two separate windows.
I'm just not very used to Apple.
Macs, yeah. I actually worked on a Mac for for a few years, but it was a while ago. I actually am a little bit out of date on that myself at the moment.
There must
Um,
be something. Why is it? Let me try. If I, it's
what
gonna
if you
just
go up
open
to
it back.
view? What if you go up to view, for instance? Remember that on the Mac, your menu is actually at the very top of the screen.
Yeah. Um,
So if you go to view, which you may already be doing, and the lag may just not
I'm
be
there.
yeah.
Yeah, I've been here a little while. That
Okay.
isn't bad lag.
Is there like a new window there? Maybe it's under file or Windows. Windows. There's a Windows item in the menu, so that's probably where you want to look.
Use tab.
Yeah, the lag's pretty bad
So
tonight. Worse than it has been in the past. So that's kind of unfortunate, but we'll live.
Yeah. Oh, ring framed front main. Yeah, it's not giving me.
Okay, well, there was something to split your window under view, right? Under the view menu. I saw it
Oh yeah, look at
briefly.
that.
Again, the lag is making this really hard to like.
Yeah. Well, I clicked on split window, but I don't know what that didn't seem to. Let me try. Oh, uh, sorry.
Okay, well, uh, hmm. Yeah. All right. Let's just. I mean, this is not ideal. This is not ideal. We really need to be able to look at these things, and you have to be able to use a REPL. Like, I don't. I don't think that that can be gotten around. So,
Well, I mean, we can go. What about this? I mean, I
yeah,
can't.
this is
I
fine.
can't look up both.
This is
Yeah.
exactly what I wanted. Right. Two windows.
Okay.
You have
Well,
two
I thought
windows.
you were.
How did you get the
Yeah.
second window? I think it's just lag. I think it's just lag. Unfortunately, though, now we have this weird thing where it's totally split over there, which perhaps we don't want. So I wonder if you can unsplit that window now.
Unsplit
The one
this
that
guy
says
over here.
session, the one that says session2.racket, that's split. You
Yeah.
see how you have the same thing in two different buffers, like above and below? Well, there's no reason for that at the moment, right? If we have two windows, you don't need to have this one split.
Yeah. I don't know how that happened. Hold on. I guess I just have to. Let me start over.
Well, when you hit split, right? Split doesn't make a new window. Split takes your existing window and it turns it into like two areas, right? So when you hit the split menu option, that's what happened here. But again, just because the lag is so bad, it's really kind of
Yeah.
hard for me to tell what's going on.
Yeah. Well, I'm getting there. I'll be there
Okay.
in just a second. There we go. I think that the only thing is because neither of these are maximized, it
Mm-hmm.
appears that in the past, I think the observation has been that increases the lag.
Well, I think it's mostly. That is true, actually, right? The more different stuff there is, the worse it makes the lag. Yeah, the maximization helps a lot. So, yeah, the lag is really too bad. It's kind of amazing to me that there are still like places that aren't in Alaska that have internet as poor as yours. But
You know, to say maybe a couple of years, hopefully, running a lot of fiber currently, but it's
yeah,
going to be a while before it,
that
a
would well,
lot, a lot. A lot.
that would be a big jump, right? Going from this to fiber. Okay,
That'll
so
be nice.
so let's take a look at what we were doing last time. Just some of this stuff. Okay, so a lot of this is we were recapping stuff. So I don't know if we
Yep.
do we need to recap the recap. We might need to a little bit actually, because the 2 week break I
I
think
know.
is possibly a little rough. But see, I guess we'll just start going, and if it becomes clear that there are some lacunae, I guess in your recollection, we'll just kind of we'll deal with them as they come up.
Yeah, that's good.
So, one of the things we talked about, do you remember the syntax for defining a function, defining a procedure? I should be more precise with my language there. Defining a procedure.
Oh boy. See, that's the yeah. Drilling down to precision. The syntax for defining a procedure. Uh, so when we say the syntax, we're talking about like the actual.
What you actually have to
Um,
type to do it, right?
right. Okay. Yeah. Um, syn- procedure.
So let's say you wanted to
It's what
write. I'm sorry.
it's after the open paren.
Well, that's how you apply a procedure to arguments, right? Is the open paren. That's how you apply it. But how do you define one? Like, let's say that you want to write a procedure that
Yeah. Yeah, it's
multiplies
the
something
simple.
by 3 and adds 5 to it, right? Let's say you just want
Okay.
to write a function that does that. So you can give it any number, and it multiplies it by 3 and adds 5.
Um,
So how would you go
I
about doing
mean,
that?
I'm gonna like I use lambda. Yeah. Um,
Okay, why don't you do that? Let's just like refresh some memory about how some of this stuff works.
um, and then uh, lambda
Yeah,
multiply by 3 and add 5.
okay. So, like, let's remember a couple of things here, right? Like, almost everything that you want to do needs to be, like, to do something, right? You remember, all right, so let's talk again about the parenthesis rule, right? What do parentheses do? What does a parenthesis mean at the REPL?
Um, it means after anything that goes immediately after this is uh, what I want the I don't know what the word would be, the computer to
Okay.
apply the action.
So, so what comes after, right? When you see an open paren, the thing that immediately follows it is going to be one of two things. It's either going to be a symbol that evaluates to a procedure, or something that evaluates to a procedure. It doesn't have to be a symbol. Anything that evaluates to a procedure. And then
Mhm.
that thing will be applied to the rest of the arguments that are inside the parentheses, which could be none. You can take a procedure and run it with no arguments, right? Depending on the procedure. Or it can be a special form. And special forms are things that have their own syntax, their own internal stuff. So define is a special form, right? We talked about this a little
Yeah,
bit. That
yeah.
special forms are things that kind of break the rules, and they can have their own syntax, and they can also they can control how their arguments get evaluated, which functions procedures can't do, and we talked about that some last time too. So we'll probably want to talk about that again. So you were typing, and I think maybe you've backspaced over it, but you had started typing lambda at the REPL. So that's not going to work, right? Because what you want to do, and lambda is a special form itself, you need to use the open paren to say, okay, this is a special form, and I want you to execute this special form.
But I'm gonna need more. Oh no, and then whoops.
Yeah, I'm way, way, way behind you. So
Oh,
just in terms of lag and stuff. So, but let's see.
let's just try it out with this. It should be 11. Nope.
So, I mean, you may want to refer back to a cheat sheet or something, right? Because I mean, you kind of have this conceptually, sort of, but like the syntax, the syntax has to be exactly correct. It can't be, you can't kind of make the syntax up. It has to be what it expects from a lambda.
Okay. Where do we get a lambda here? Five would be better. So,
You may
but
not
do I
have
need
you
to?
may not have one over in that rate thing because we weren't really talking about. But there you go. There you have one. Oh no, you actually you do, but you have to understand the context of what you're looking at here. You don't have like a bare lambda anywhere in here. You have an example
A
of
bare lambda.
like what you're trying to do now, creating a lambda just by itself. That last line, line
Uh-huh.
13. What is that last line doing? Do you remember what line 13 there on the right hand side is doing?
I mean, it adds. It's a lambda that. Mm,
Well, that's a lambda that adds two numbers together. But note that it's actually being applied, right?
within the lambda.
Well, you see how there's two
I
parens
mean,
at
with
the beginning? And then there's the arguments, 7
yeah,
and 8. So that isn't just like creating a lambda. That is creating a lambda and applying it to some arguments, right?
Oh, so if I wanted to, right.
So if you just want to create the lambda, which isn't very useful because it's going to go away right after you do it, but let's just get the syntax for just creating a lambda here. It's not going to do anything, right? It'll create the procedure
Yep.
and just throw it away. It's an expression that will evaluate to a procedure, right?
Okay. Um,
So let's talk about this. Let's go over this from the beginning. I do think you need to like probably look at this stuff a little bit during the week though, because otherwise it's just like
yeah.
we're gonna basically do the same thing over and over forever. Otherwise,
Well, I mean, I need to, and I also need to. I was just opening my notes over here because it's awesome. I mean, it's the terminology. The terminology like follows the logic, and so if I don't have the terminology
right?
correct, I like keeping the logic.
Yeah, the terminology is pretty important. So let's think about it this way, right? So a lambda is a special form. Okay, that's one thing to note about a lambda. So a lambda has its own syntax, right? Because
Mhm.
scheme, if you leave the special forms out of it, scheme is an incredibly, incredibly simple language in terms of its syntax. That open paren rule is practically the only rule in scheme syntax other than outside of special forms, right? That's pretty much all scheme is like open paren, something that can be applied,
Yep.
if you were to leave special forms out of it, that's the whole thing. You have open parens, you have procedures, you have arguments, you have closed parens, and you can nest those within each other. And that's practically the whole language if you completely ignore special forms. But you can't completely ignore special forms because you need some special forms to do anything useful, right? So lambda is one of them.
Well, yeah. I mean, unless you make your own special forms, right? But then you have those.
Well, it is possible to make your own special forms, but that is significantly more advanced than we are at the moment. But you have to use
Sure.
some of the built-in ones though, because otherwise, it's you just need them, right? There are some things you need to be able to do that you cannot do by calling procedures, and creating procedures is one of those things. Well, I mean, I don't. Obviously, that's not exactly correct, right? There are ways of creating procedures only using procedures that are built in. We looked at that some last time. But basically, when you want to create a procedure, you're going to use either lambda or you're going to use define, right? Because define has a shorthand for using a lambda and binding it to a name. So,
Yep.
so lambda has its own syntax, and so the rule with lambda is that there's basically three parts to a lambda, which is you have the keyword the symbol lambda, right, which just says okay, this is the special form that that
Yep.
we're going to be using, and then you have an argument list, which is just a list of what arguments the procedure takes, and so that's a list of names, and the arguments that are
Mhm.
passed to the procedure will be bound to those names. And then you have a body, and the body is so one thing we talked about a little bit last time. We used the phrase S expression, right? The body is going to basically be an S expression, and an S expression is basically, I don't want to define it technically, but it's basically something that can be evaluated at the REPL, something that can be evaluated and that will produce a value, which could possibly be the absence of values, right? That's always a possible value.
So you say an S expression, the lowercase s. I mean, the letter S.
The letter S, yes. It's just what they're called, S expressions. Most of the stuff we're looking at is S expressions. If you type in open paren times 4, 5, close paren, that's an S expression, right? You can evaluate that. That actually produces a value, and it doesn't throw an error. If you type in 5, that's also an S expression, right? The trivial case is that it can just be a value that evaluates to itself. So yeah. I'm sorry, not an S expression. I'm getting my terminology really mixed up here. Those are S expressions, but what I mean is a form. That is what I mean to be saying. I'm sorry, I am a little tired. What I mean to say is a form, which generally are S expressions. S expressions are not they're not synonyms.
Yeah. Yeah.
Forms are S expressions. Not all S expressions are forms, but a form is what I mean. And a form is something that you can evaluate that will get you a thing. So lambda has three forms inside of it. And form is a word which, if I don't get confused in the future, which I might, again, form is a word that we're going to use a lot because it's very convenient way to refer to sort of the units of things. And they're top level units, right? Forms can contain other forms. But even a form that's got other forms within it is still a single form, right?
Oh,
Does that make sense?
yeah.
Okay. So if I have like plus, let's just do this for a second. If you want to maybe backspace over the lambda, like, okay, so you remember how to add two numbers together, right? Like plus 5, 6. Take the sum of 5 and 6.
Done. How lad's the lat is. Have you seen it yet?
No.
Okay.
Nope. I just
That's
saw the
annoying.
paren up here. It is annoying. But okay, there we go.
Um,
So,
I think I think I can always jump back over. I don't think it's worth it to for the lag. I should think I should just maximize and
okay, why don't
you
you
know what I mean.
maximize for the moment? Yeah. Yeah.
Okay.
Okay. I'm waiting for it to maximize. That may actually really take a while because it's a lot of pixels changing. Your internet does seem worse this week than it has been in the past. I don't know.
I think there's a couple. There's I don't know what else is happening in the in the.
Yeah. Yeah. Um,
And actually, we got a storm going right now too, so that probably doesn't help.
okay. So I can see this. Okay. So you took the sum of 5 and 6. Okay.
Yeah.
So that plus
So
sign is actually a form by itself. The 5 is actually a form. The 6 is actually a form. All three of those things are forms. If you were to type them into the REPL and evaluate them, they would all produce values, right? Like if you type in the 5, what would you expect to get back? You don't need to do it, but just what would you get back?
value is the five. Yeah.
What would happen if you just typed in a plus sign and hit return at the REPL?
Give me a plus sign. Whoops. Oh, okay. Right. It tells me it's a procedure.
Right, you get back the procedure. It's not so much even that
Oh
it's
yeah.
telling you that. It's returning the procedure as a value. That's what a symbol, symbols are bound to things in your environment, and these symbols happen to be bound to procedures. And so this is really important. This is what we're talking about when we talk about this parenthesis rule and the thing that comes after the parenthesis, evaluating to a procedure, right? It evaluates. When you evaluate it, it evaluates to a procedure. That's what that name is bound to.
Yeah.
So so already
And
this is
what's the hashtag symbol called again? At the beginning of those lines,
that's a
that
sharp usually. And
sharp.
that's just
Yeah.
there because that's how Racket chooses to print procedures, right? Because there isn't a really sensible way of printing a procedure, right? What is a procedure? How do you print it? So it's just kind of telling you it is a procedure, and
Mm-hmm.
it's, we don't have to worry very much about the print representation of it, right? Just note that it is a procedure that you are getting back here.
Yeah.
So hang on one second. I am getting. Yeah, okay, I'm getting texted. But I'm going to ignore it for the moment. So, okay. So, so where was I? That kind of
Well,
distracted me a little bit. So we're
we're
talking about
coming.
forms. We're talking about forms.
Yeah.
So how would you say? Okay, so that is how you get the sum of 5 and 6. Let's say that you want to multiply the sum of 5 and 6 by the sum of 3 and 4. How would you go about doing that?
Um. Well, so do I don't need to. All 5 and 6, but some 3 and 4. Can I do it like this?
Yep.
Yeah. Okay.
So let's note something. That whole thing is one form. Okay.
Yeah.
It has an open paren, it has a closed paren all the way at the very end. You can evaluate it at the REPL. You can just evaluate it in the environment that you're currently in, and you get a value back. But note that it has other forms within it, right? That star at the beginning of it, that is a form, right? A symbol is by itself a form. And
Uh-huh.
then the second form that you have in there is that you have like this open paren plus 3, 4 closed paren. That's all one form, right? But it too
Gotcha.
contains subforms, right? The plus sign is a form itself, the 3 is a form, the 4 is a form, and so on. And so what I could say is, this is a form, but it's a form that contains 3 forms. And the second form itself contains 3 forms, and the third form contains 3 forms. So I just wanted to get that out of the way because you were saying terminology matters, and it's absolutely true. This is a piece of terminology we're going to want to use a lot. So when we look at lambda, lambda has 3 forms. I've been saying it has 3 parts, it has whatever. It's better to say lambda consists of 3 forms. So you have, you open a paren, and the first thing in it is lambda, right?
Hmm.
I don't know if you're typing or not.
Oh, yeah, no, sorry, I was making a note there, and
Gotcha. Okay. I just don't really know if the lag. I'm not sure if it's improved or not.
right.
Yeah. Okay. I think it probably has improved though. Yeah, this maximization thing really does sort of work. It's a little bit annoying. That's
Right.
going to get hard to deal with at some point. It's okay now because we can just work in Racket. But okay. So lambda.
So lambda's we're talking is it?
Lambda is
Yeah.
the first thing, right? It's just saying this is a lambda. It's saying we're starting a special form now. And as I said, special forms have their own syntax. So
Yep.
the next thing in a lambda, the next form in a lambda is an argument list. And this could be empty if your procedure takes no arguments. It still has to be there, right? You would just have an open paren and a closed paren in that case if you were writing a procedure of no arguments. But in this case, so we wanted to take something multiplied a number by 3 and then added 5 to it, right? Just as an example. Well, so no, hold on. This is the argument list. So the argument list of a lambda is where you tell it what the arguments are. It is a list of names, and those names will be bound to the values of the arguments when you apply the arguments to those values. So how many arguments is this procedure going to take?
I think it's going to be 2, right? It's multiplying the thing by 3 and adding by 5.
So what are the 2? What would the 2 things be?
Well, okay. So is it only 1 because you're just taking one number
It's just
and
right. It's just 1. You're taking a single number and then you're multiplying that number by 3 and adding it
yeah.
by 5. The
Okay.
arguments are the things that can be different within the function. The times 3
Got
is
it.
always the same, right? The 3, it's always
Yeah,
times
yeah.
3. The
Okay.
add 5 is always the same, but it's what varies within it. They're called variables in a lot of languages. I kind of think we maybe don't want to use that word necessarily at the moment. But so this is just a list of those and what names you want them to be bound to, right?
Okay. Right. And in this case, because we're only expecting to put one value, one number into it, it's just one
It's just 1.
thing, which we could call X or we could
We
call
could call
whatever.
X. We could call it whatever we want. X would be a good name here, though, because there's no special, we don't really know what this is, so
And then I close it.
then you
Yeah.
close it because it's just a
Yeah.
list, right? It's just a list of things.
And then what's the next thing called? Is
It's the
or
body.
the third form is the body.
It's the
So
body. And so
I've got lambda, the argument list, and the body.
lambda, the argument list in the body.
But and then that's just now do I need? I'm gonna need got 2. So there's 2 forms within the body. Is that
Actually, you're not going to need double parens here. So let's
oh,
think about what the body actually is. When you
okay?
actually apply it, let's write it out, and then we'll take a look at it and take a look at what the body means. It'll be easier if we have it and then if we apply it.
Yeah.
So okay, that's exactly right.
Okay.
Oh, I'm sorry, I was wrong. I'm totally wrong. You were absolutely right. You do need double parens. You don't need double parens, right? You don't need double parens. This isn't going to work though. I am tired. Double parens is not going to work, but this is also not going to work. Why don't you keep going, and I think you'll see what I'm getting at here.
Keep going with what I'm doing now.
With what you're doing.
Well, I need okay.
You don't need double parens at the beginning, but this isn't going to work. So if you close this, This is actually legal scheme, but this is not what you want. Because I lied a little bit about the body being a third form. Like you can actually have an arbitrary number of forms in a lambda. This isn't going to do what you think it is, though. This is just going to add 5 to some. This is actually just going to return 5. That lambda will always return 5. We can talk about why that is.
Is that back to like it throws out everything except for the last?
That's one reason. The other is that you never used the argument, right?
Yeah.
You have to actually use the argument in the body for it to, for it to make a difference.
So if I had done double parens at the beginning, before lamb.
Double parens isn't going to work either. Like, so let's think about this. Let's forget about using a lambda. Let's just assume that we want to perform this operation that we're performing on the number 10. We want to multiply something by 10 and multiply 10 by 3 and add 5 to it, right? Because that's what we're doing, is we're multiplying some argument by 3 and then adding 5, right?
Yep.
So how would you write that? Like, not using a lambda, just do it with a 10, right? Multiply 10 by 3 and then add 5 to it.
Uh, mm, so I'm gonna be the open thing. 5. I think I'll do it like this one. Oh no, I'm gonna need more. No, I don't think I do. I may have to go back and. Five? Yeah.
Okay, that's exactly right. So here's the thing, and we want to talk about this. Probably let you define the lambda first, and then we can take a look at this. The body is going to look exactly like this, but with the thing that varies replaced with the argument. And when you understand that, this whole lambda thing will become extremely easy to think about. This is actually the critical point about what lambda does.
Mm-hmm. Okay.
Like, you know how to write this out if you have a constant value, a 10. You know how to write this out. The thing is, you just want to make it able to vary. So what you want to say is, you want to write it out with an x in it, just like a mathematician would. But to make a procedure like that, you have to actually say, okay, there's going to be an x, right? And then you just provide the body, and that body will get evaluated.
Okay, so then I put
x replaced with what the argument is.
That makes sense. So it would be, whoops. Well, so so here's the thing. How do you know if it worked?
So you have to actually try applying it to an argument, right?
Yeah.
So how would you go about applying that lambda to an argument?
I'd have to put it in the same line. And can I just take the thing and can I do it like this? And whoop.
Okay. Yeah, you may want to.
Is it?
So how do we apply procedures to arguments? What's the rule? How do you apply a procedure to an argument?
How do you apply procedure?
Like, addition is a procedure, right? So how?
Yeah. You gotta have it inside. Gotta have it inside the parens, I would think, is.
Yep.
When
that's exactly it.
Yeah, I was just trying to copy and paste that part of it, but the shortcut for some reason I seem to be having a problem with the copy and paste function of Mac. So then.
Now you do have one small syntax error in there, right? Which is the plus and the 5 are all jammed together.
Oh, whoops! Thank you.
Yeah.
Yeah, that one's a little bit hard for me to get to. So if we're going to do it with 10. Whoops.
Yeah, I think that's not quite right because the parens aren't quite right.
expected number of items did not match the given number expected. I didn't give them an argument. I guess that. Let me just look at these prints. So that. Oh, I got them in the wrong places. I gotta close the lambda first. Yeah.
Right. Close the lambda, but don't close the first paren because you need to have the arguments inside that, right? That's how it
Right.
works.
Right.
Okay.
3 times x.
This isn't quite right either. Okay, so you have to really think about what the actual forms mean here, right? Because
Oh,
there's a
whoops.
meaning to it all. So if you think about what it means, right? Exactly. Yeah.
Nope.
Whoop. There you go. Close the lambda up.
Yay!
There you go. Okay. So here's the thing about lambdas. Okay, when we define this lambda, we could bind it. We could bind this to a name, right? Do you remember how to bind a lambda to a name? How to bind anything to a name
Yeah, I mean with define,
with the
but
okay.
so if I wanted to do this now,
So why don't you call it like foobar? That's something that programmers have used. I don't know if do you know the origins of foobar? It,
I don't think I know the origins, but I definitely was a pretty popular one when I was a stagehand because
I
this seemed to
imagine.
be.
Yeah, it's actually an old military term, but it is an abbreviation. I guess we are streaming. I won't say what it abbreviates, but not that
Look
I
it up.
think we're gonna have a
One.
lot of people watching this. But so a lot of the time, foo, bar, baz, I don't know. They're just sort of nonsense words that historically have been used a lot in programming. So
Mhm.
let's just let's just
Well,
mhm.
I'm just thinking about define because define is a special form, and um, if I was just defining, I don't need to have a parens. Uh,
Well, do you
I,
remember how to? Do you remember how we defined pig to be 42? Do you
yeah, you
remember
just
that?
said
Okay, well, you
fine.
do need to open with a paren, right? We were talking about that at the beginning, right? Like to do just about anything, whether it's to apply a procedure to arguments or to use a special form, to make a special form do its thing.
Apologies for the lag. I guess I did. Sorry, I was remembering it. Yeah, I was looking. Okay.
Okay. Yeah.
Um, and then and then I say what I want my define to be,
Right. So
right? Define foo
just like lambda, define has, at least
the thing that the
the
thing that
normal
immediately
syntax for define, right? Exactly.
will
And
be the
foobar is actually traditionally spelled with two O's. You can spell it that way if you want, but in programming circles, it's
neon.
FOOBAR.
Oh, let me. That's I've the A for me there is what are the I mean is all. What are the two O's stand for as an acronym? Did I lose you?
No,
What
I'm
happened?
here. Okay, so it's not
Oh.
FUBOR usually. I mean, this doesn't really matter at all. But you're gonna see
I
this.
know I'm just curious now.
You're gonna see this all over the place in literature and stuff. Programming literature.
Which
This is used a lot. It's FOOBAR is typically the thing, right?
FOOBAR?
FUBAR.
Oh, oh, it's the way it sounds rather than the actual acronym.
Yeah, I mean, it doesn't really matter. You can feel free to. I
Yeah,
don't know
yeah.
whether people were sanitizing it or what the reason
That,
for that is. This is just a
that makes
very commonly
It's
used.
one step to throw them off the trail. I mean, speaking of
Exactly.
stage hands, like why is a light bulb a lamp? Well, different thing. Sorry, I get a little bit loopy when I'm tired sometimes.
Yeah,
Um,
me too. I'm actually pretty tired as well, but
um, I'm hitting my second win, man. I'm now beyond to where I'm loopy and tired, but like I have that
getting
weird.
energetic.
Yeah.
Yeah,
Okay. But what are we doing here? Let's get back to business.
yeah.
No, we want to do the because we're gonna. Okay, so would we? So this will allow us to call the procedure up again that we are defining in this lambda.
Right.
So I don't necessarily need. So I could do. Whoops. Again. That looks good. Yeah. And then I should. And let me just think about this for a second. And then could I? Well, what did I do wrong? Oh, you gotta. Yeah.
And
Tell me.
now try applying it to 10.
So it doesn't tell you made a procedure?
No. And let's
All
talk
right.
about that for a little bit. So it's not so much telling you that you made a procedure when you type in lambda. When you type something at the REPL, right? This is sort of the most fundamental rule of the REPL, right? Remember that it's read, eval, print, loop. Okay?
Yeah.
That's what REPL stands for. So it reads your input, it evaluates it, then it prints what it evaluated to. So lambda evaluates to a procedure, right?
Mm-hmm.
When you use lambda, it evaluates to a procedure. Define evaluates to no value, right? Define is being used purely for its side effects. Do you remember we talked a little bit about side effects?
Mm-hmm. Yep.
So we don't care what value define evaluates to. That's not why we're using define. We're using define to change something about the world.
Yep.
That's sort of what a side effect is. And the thing that we're changing about the world is that you're within an environment right now, and within an environment, names can be bound to values. So when you call define here, what you're changing about the world is that in the environment that you're currently in, the name foobar is now going to be bound to whatever the third form in the define is, which in this case is a lambda, right? That lambda is going to get evaluated first. And then foobar is going to be bound to the value that that lambda evaluated to. And if you recall, the lambda evaluates to a procedure. So foobar gets bound to the procedure that the lambda evaluated to. Does that all make sense?
Yep.
Yeah.
I got it.
Okay. So define just doesn't, define returns a lack of values, right? It's the absence of a value. That is something that something can evaluate to. That is, in a sense, a value. It's a little.
Oh, I got it. Okay, so because and that's really since it's the first thing in the first parens, that's what that whole line is accomplishing.
That whole line is one form, and that one form is a define. And remember, we talk, when we say special form, right? Note that form is in there, right? A special form is a single form.
Mm-hmm.
So.
Yep.
So that worked. So let's take a really close look at what's happening here. So you have this lambda, right? And say that there's three forms in the lambda, and the first one, of course, is just the symbol lambda to say this is a lambda. That's what we're doing, right? The second form is your argument list. Your third form is your body. So here's the key thing. When you type in foobar 10, it's exactly as if you had typed in the body, but replaced the x with a 10. And note that that's exactly like what you did up there when I asked you, can you do this to a constant, right? Just a 10, right? So this is what lambdas do. This is really what they're about, is just about binding names to values. This is a much deeper idea than it looks like on the surface, though. And it turns out, we talked a little bit about how, there's a formalism called the lambda calculus that essentially can be used to define all of computation, right? So this whole thing of binding names to values in arguments is actually, it has a lot of very deep implications. We're not going to worry too much about them right now. We're just going to say this is very convenient for us because we do need to be able to create things that can operate on more than one value, right? You can't just always be typing in constant values, right? You need things that can,
So it binds the name to the value, which in this example is binding the name of X to the. Why is that called why is the this, plus 5 and the parentheses and all that. Why is that called a value? I mean, it's
the body.
the bot. Right, but you're saying
It's
the
binding
lambda.
x to a value. The value is 10 in this case.
Oh, yeah. Oh, okay.
So what happens is that it substitutes in the body as if you had typed that, essentially, right? It's equivalent to doing that.
Mm-hmm.
So calling foobar 10 is equivalent to typing in that open parens, but having that name be bound to it. So here's maybe something we can do. Why don't you define y to be 10?
Do I just do this?
Yep. So now if you type in y, okay, right? Because that's the rule for symbols. If you evaluate a symbol, it looks for a binding for that symbol in your current environment. It says, is this symbol bound to some value? And if it is, it evaluates that value. If it's not, it's an error. If you typed in W, you would get an error right now.
Okay.
So yeah, you can do this. But what I actually wanted to suggest is, why don't you try writing it out longhand, add 5 to 3 times y.
Times instead of the x, you're saying?
Yeah, just I mean, it's not really instead of. You couldn't do this with x. And maybe we'll show you why in a second, because that's something to be very clear about. But, so that works, right?
Sure.
So what happened there is, this works because this is just the way that the rules of evaluation in Scheme work, which is that it starts evaluating everything, and it evaluates it kind of inside out. Unless you're in a special form, because special forms can alter how things get evaluated. But if you're not in a special form, like, it's going to look at this and it says, okay, I have addition. So I want to add 2 things together. What are those 2 things? One of them is 5. One of them is another form. I don't know what this form is, so I have to go evaluate this form. So it says, I'm going to evaluate this form times 3y. Okay, great. That's the multiplication of 3 times,
yeah.
Y,
No, I feel
y evaluates to the 10, right?
Yeah, it feels logical to me because this is how I remember doing whatever kind of math this is. You'd have to.
Sure.
Yeah.
Yeah, you do this. Now, what would happen if you typed that in? Don't do it yet, but what would happen if you typed that in and put an x where the y is?
Well, x where the y is. Ooh, it's x at nothing. We haven't really. X is not.
Well, you'd get an error. Try typing it in, and if you want, if you feel like it, you'd get an error. X is not bound to a value within this environment.
Yeah. It's just within that one line up there.
So this is what I'm kind of trying to get at, is that what happens is that the lambda creates a new environment.
Mm-hmm.
Right? This procedure gets its own environment. And what the lambda is doing is saying, so when you substitute this template in, you've got a template, right? So applying the lambda to the argument basically just evaluates that template with an environment that has bindings that correspond to the argument list. Do you see what I'm saying? So in this case, it's going to evaluate plus 5 times 3x, and if you've applied it to 10, what it's going to do is say, just for right now, only during this body, I'm going to have an environment where x is bound to 10, because I have this argument. And that's what this second form is in lambda, is saying this is the argument list. This is the list of names that, while we're evaluating the body, are going to be bound to values, and those values are going to be supplied as arguments when you apply it.
Mm-hmm.
So if you, when you did foobar 10 up there, it's exactly like putting in that template that the body is, and then substituting whatever the argument is for the x, right?
And I know that we worked on lambdas with more than one argument in the argument list, But it's like now that we're in this example, I'm like, how could that possibly? How would it know which one to apply to what?
It's the order. It's the order in which they appear when you're applying it. So let's write something with let's write sum of squares again. Okay? So sum of squares takes two arguments and it returns you the sum of the square of each argument, right?
Yeah.
Actually, let's not do that because that's sort of symmetrical. Right, in the sense that it wouldn't matter if you transposed the arguments. Right, the order of the arguments doesn't matter in sum of squares.
Yeah. Right.
You
Yeah,
get the
yeah,
same
yeah,
thing
too.
either way. But let's say let's say that we want to sum the product of squaring your first argument and cubing your second argument.
Okay. Right. And we want to define it. So
Yeah,
use
name
it
this
again.
like Fubaz with a Z on the end. Yeah, just
Cool. Okay. So, and again, we could have the arguments named anything.
we can name them
Um,
anything we want. In this case,
so,
let's just name them X and Y. But
okay.
okay, but it's a list of the arguments.
Oh, so it's all in the same
It's all
Hula,
in one.
right?
Right.
Because it knows how to. My brain
Remember,
doesn't.
it's a single form. The argument list is a single form.
You're right, and the space makes them discrete. So
Yes, yes, it
yeah,
can tell the difference.
right.
What you were typing, the third one, it would start being like, no, that's the body, right? Because that's how it knows what they are. It's their position, right? So it has to be like form, body, right? Because when it sees that third form, it's like, this is the body.
It sees the third form as indicated by the new paren.
Within the lambda, right? It doesn't have to be a paren. Does not
Oh,
have to be a paren. It can be any form. And we'll take a look at that in a second. But
but in this case, we want to have
so
uh, we want to do we wanted to do multiply x.
now remember that in this case, at least,
Oh, whoops! We wanted to add the two of them
right?
together.
We want the body to be a single form in this case. There you go.
But I need to do
Now
this.
there you go. That's exactly right.
Add this one. That is also going to be a multiplication. 3 times? Is that? I think that's.
Sure. That is how you cube things. Either that or you pound them with a mallet with spikes on them if they're steaks. But
If they're what?
if they're steaks.
Yeah. Okay. Right. Exactly. Yeah. Or, anyways, no, I'm not gonna. I'm not gonna be able to. That's the best we can do for now. All right. So.
Or you just gleam them if you're in the mid 80s. But
And now to test it. Wait a second. So I want to do a fubaz, but I'm gonna have to do x.
no,
Whoops.
nope. The names are totally irrelevant, remember? Like
Yeah, right. We lost that. Oh, okay. But that all right. So it'll be the first. There'll be the first form, and then the second form. It'll
right,
be
you literally just give it the arguments one after another. Just like
argument.
times, just like addition. What happens if you're adding two numbers together, right? You say add and you apply it
Yeah.
to
Yeah.
it's exactly
Got
the
it.
same thing.
Yeah.
Addition is a procedure. Fubaz is a procedure just like addition.
Let me think about some numbers that will make it pretty easy to have result in it.
I would use small ones because frankly
Yeah.
I don't want to do a lot of math in my head, right? So
I mean, 10 is 1,000. We should get
well,
1,000.
true. That's true.
1,000.
That's easy enough to do. Yeah.
Cool.
Yeah. So how does it know which one to do it? It's the order of the arguments, right? If you were to type in Fubaz 10.3, you would get what, like 127? Am I right about that? I think so. It is late, but I think you'd get 127.
Yeah. Yep.
Yeah. So, yeah, so it's the order, right? So this is what's happening. And again, if we take a look at what that lambda does, right? We take a look at it. When you type in fooBAS 310, it is as if you typed in the body of the lambda. Like, let's imagine that you'd already defined x and y just at the top level to be 3 and 10. Well, if you typed in that body, right, you would get this result, right? Because it would be looking them up in the environment and it would get them. Just like when we defined y to be 10 and then we typed in plus 5 times 3y, right?
Yeah.
It just sort of evaluated, it evaluated that form, that expression, plus 5 times 3y. It evaluated the y. It said, how do I evaluate a y? Well, I look in the environment and I see if this symbol is, if this name is bound to a value, right?
But because we have the lambda on that line up above here, it's shielded from the overall environment, which is just nice.
That's right. These haven't escaped into the environment, right? Like, while we were evaluating that body template, X was bound
Yeah.
to 3. But if you type an X at the REPL right now, you're going to get an error.
Yeah. Yeah.
And let's note something. Y, while you were bound, oh, well, this isn't a good example because you bound Y to 10 and that's what Y is defined as. But try doing, yeah, well, you don't even have to try doing it. But let's say you did fooBAS 3.8, right? So while it was evaluating that body template, essentially, while that was happening, Y would be bound to 8 within that body. But as soon as you come out of that, Y is right back to be bound at 10. You haven't affected that outer binding in any way.
Yeah.
Okay.
Yeah.
Which is really, really important, right? You don't want to have to worry about like stomping on, we could call, we're going to say that Y in this case, the Y that you would get if you typed it right now, we're going to call that a top level binding right now. But in a lot of programming languages, you would call that a global variable. And really, as shorthand, I could call it that in Scheme 2, a global variable. It is globally visible, right? And global variables need to be used very, very sparingly, especially if you're going to actually change what they are bound, what values they're bound to. It gets very, very dangerous. And if you did you do any like basic programming when you were a kid?
If I did, I wouldn't remember. Oh, well, I mean, who knows what I would remember, but I don't remember doing it.
Okay, yeah, it was pretty common. That was pretty much what schools had in the era in which we went to school. Was they had little programming classes with BASIC, and of course that stuff was all a whole bunch of global variables, and it was a mess. It's very hard to keep track of. So, so yeah, we want this isolation of names, and we also want to not have to care about what the lambda named it. Right? We don't have to know when you're doing fooBAS 310. You don't have to know, and there isn't any way, or at least not any straightforward way. There's no way to know what that lambda called things. Right? You just don't know. And depending on the implementation, in fact, the names in a sense could have gone away. We won't talk about that though. But, right, it creates its own little environment and it binds values to these names and it binds them to the names that are in the argument list. So lambda becomes very easy to remember once you understand like why the pieces are there, right? Because they all serve a purpose. I mean, lambda's there to tell you what's a lambda, right? So that one's trivial. But you have an argument list, which says these are the things I want to bind to values. And then you have the body, which is a template that, it's an expression that gets executed and within an environment where those bindings exist. That's really all it's doing, right?
Yep. Okay.
So, do you remember the define special syntax for defining because you can do this. You can type out the lambda. It's clunky syntax, though, to type out a lambda all the time, right?
Well, I mean, how do you...
So define is a special form, which means that define gets to make up its own syntax. Let's go back and talk about one thing here that we talked about a little bit last week, but that I just want to talk about again. So we have this rule in Scheme, right? What does an open paren mean?
It means evaluate the next form.
Yeah, and if it's it's either going to be, the next thing is either going to be a special form or a procedure. Or it's something that evaluates to a procedure, something that's bound to a procedure, right? And then apply that. But let's take a look at the lambda here. The lambda is not following that rule. Look at this argument list. The argument list, like, it opens with a paren, it's got an X. The normal rule would be to try to like evaluate X and make it a procedure and then apply it to Y, right? That's normally what an open parenthesis
Mm-hmm.
means in Scheme. Note that that doesn't happen
Mm-hmm.
when
Okay.
you do it in the Lambda. And that's what makes special forms special. One of the things that makes them special is they can have their own. You couldn't write a procedure like this that took like a list as like that in the first as its first thing, right? It would. You can't write a procedure that has that syntax. You need to have a special form to have that syntax. So define, because it's a special form, it can have its own syntax. And that syntax can be within limits, whatever the person who defined define wanted them to be. Okay? So define has a special syntax. We talked about this a little bit before for defining a procedure and binding it to a name in sort of one step without having to type in Lambda. It's just syntactic sugar, really, over the Lambda.
Mm-hmm.
You're doing exactly the same thing that we've been doing here. But it's a little bit easier to write. So do you remember what that syntax is?
No, I don't.
Okay. So let's just talk about it again. The difference is, so normally when you define, you've got define, and then the second form in it is a symbol. And
Yep.
you're binding that symbol to some value.
Yep.
But you can also give it a list instead of a symbol as the second form.
Okay.
And
Right.
what happens when you do that is it's a list that is just like the argument list of a lambda,
Mm-hmm.
except that it starts with the name that you want the lambda to be bound to. And then the third form is just the body that you would have used in a lambda.
Got it.
So how about defining foo backs to be, say, the same thing that we'll... Okay, let's make it a little bit different. Like in this case, let's cube the first argument and square the second argument.
Right.
Otherwise, have it be the same. So, okay. But remember, nope, the second form is a list.
Oh, yeah.
The second
Yeah.
form is a list.
So I don't. Okay, so the first form is the name that you're bounding the
No,
values to.
the first form is define.
Right. Okay. Yeah. Oh wait. So
second-
the second form is a list, so it needs its own.
It needs to begin with a paren. And
Yeah.
then it's got the name you want to bind the procedure to, but then it's the rest of it is the argument list that you would have had, right? If you take that name out of there, you get the argument list you would have used for the lambda, right?
Gotcha. So it would be basically the same deal.
That's right. And then it's just the body.
Okay. And this is the okay. So we got the first form is defined as a special form. The second is the argument list, which includes the name that the entire form is being bound.
That the procedure that you're creating is being bound to.
Yeah.
The procedure will wound up bound to this name.
So, and then we're going to want to do adding. What we're saying, we're going to cube the first, and then
Yeah, we'll cube the first this time, and just to make it slightly distinct from Fubas.
right.
Um,
And
yep. And now you could try applying Fubas to something. That is Fubax.
Isn't that what we were doing? Yeah.
Fubax. Okay, yeah, okay. I'm sorry, I got confused. Right, Fubas is.
So now, if we switch the numbers, we should get the same result.
Yep. Yeah.
Because, okay, yeah, that makes sense.
So when you're defining a procedure that you want to hang around, right? That you want to actually be bound to a symbol. That's normally how you make things hang around.
Yeah.
You almost always use the define syntax for it because it's so much more compact, right?
Got it.
It would be a little bit strange to come along and see somebody having written the whole lambda out in Scheme. You typically wouldn't do that. There are plenty of reasons to actually write lambdas out, though, right? When you want to do something other than bind them to a name at the top level, you write the lambda out. And that could be that you want to have a little procedure that does something, and you want to just, but you're only going to use it in one place, right? You're probably not just going to apply it to arguments, because what's the point then? You could have just written out the body and put your arguments in there, right? But for instance, you could apply it to several things in a row. We looked at that last time, and I think we'll probably want to look at that again, maybe right now, in fact. Do you remember map?
don't. Let me just take a quick look because the maybe it'll. I know it's a little slow stuff down here, but I'm opening back up the section. I'm gonna see if it's. I'm just curious to see if it'll jog my memory, but maybe I didn't. Not seeing map. I'm scrolling through my notes from the last
Yeah, it
time.
was there. I saw it. You scrolled by it, I think. Maybe
Oh,
we
did
should
I?
actually look at stuff in roughly the order we did last time, actually. So let's go back up then. Let's see. So we had square three, right? Right. So that you see where we have that defined square three. Okay, yeah, you're scrolling and lagging at the same time. So
Sorry.
yeah, it's okay. There's nothing to be done about it. But you see on line 18,
Give me.
you see on line
Yeah.
15. Um, that's
Yep.
exactly what we were. This is the same thing, right? You can see we're doing the same thing with that defined, the special syntax of that. Quote. We talked about quote a little bit, and quote is something that probably you should have. So yeah. So for instance, let's see. So what are the things we want to look at? Quote, and then predicates and booleans. Yeah. So let's jump over to the other window. Maybe maximize it again.
Right. Maximized. I know it takes a second once we're
Yeah.
there.
It'll be a moment before I see things. Oh, well, I was going to say actually maximize your working REPL
Oh,
so we can do stuff in it.
gotcha. Wow.
Okay. So, yeah, the lag is fair. It's not so bad when the windows are maximized, but otherwise
Yep.
it's pretty terrible. So, yeah, so quote. We should talk briefly about quote. Quote stops evaluation. That's all it does. It
Okay.
stops evaluation. And so you remember? Did you remember we talked about like the use mention distinction a little bit?
Yep.
Right? So we run into a problem sort of with the use mention distinction. For instance, when you type in a symbol at the REPL, what it does is it evaluates it. It looks for what it's bound to. What if you want the symbol itself, right? Like the plus sign is a symbol, right?
Yep.
But if you
Yep.
type it in, you don't get the symbol back. It doesn't evaluate to itself. What if you wanted that symbol itself? How would you get at it? And the answer to that is quote. So if you type in open parens, quote, space plus close parens, right? Note that quote is a special form.
Mm-hmm.
Because this is another thing. Okay, well, quote does have to take something. You have to quote something.
Yep.
Yeah, you get that symbol back, right? And note that it doesn't blow up. It doesn't give you an error. X is not bound to anything. If you just typed X in here, you would get an error because it's like, what do you mean X? But the
Yep.
symbol X is just the symbol X, right?
Yeah. Yep.
But unlike
And so
numbers,
when it stops evaluation, it's all it's doing is reading. It's not trying to, reading and it's so reading, read, evaluate,
exactly.
reading,
It's like
and then
it reads and then it basically prints what you gave it, right?
yeah.
In the REPL, but in code, obviously, right? That's not necessary, in code. So, yeah, try typing in quote, yeah, quote space fubas 310, right? Well, you use an open parens, as if you were applying it to arguments, right?
Gotcha. Yeah.
You just get it back. Nothing was done. So we talked about lists briefly last time. I don't know if you remember them. We'll talk about lists again. But one thing to note about Scheme is that Scheme code is made up of Scheme data structures. And this is not really the case with most programming languages, except in the very trivial sense that most programming languages do have strings as a data structure, right? So you could consider a program just a string of characters, but that's a totally opaque. That's just a blob. It has no structure to it, right? But this is actually a property known as homoiconicity. Scheme is a homoiconic language in that scheme programs are just scheme data structures. So when you have like fooBAS 310 in parens like that, what that is a list. That's the scheme data structure that represents that program. But when you evaluate that list, the basic rule is, well, you see the open paren, you see the fooBAS, you see the 3, the 10. It evaluates it. So it applies the fooBAS to the arguments. When we quote it, we just get the list back, right?
Yeah.
And we'll talk about lists again in a minute, but I did want to point out quote, because quote's going to be important. Maybe we'll just talk about lists right now, in fact. So you can use the procedure list to make a list. Okay, so if you like open up a paren and type in list 345, for instance, well, list 345, L-I-S-T, the actual word list, the symbol list. Okay, we get a nice list back, right?
And it's got the little symbol thing there.
Right. It does, because it's saying, like, it's the same thing you'd get if you sort of
quote.
Yeah. You can also, there's one actual thing about quote that I guess I should mention. Right. I kind of forgot this. We've talked about it before, but I should mention it again. There is a shorthand syntax for quote. So, which is almost always what you use, to be honest with you. You don't usually type the quote out. If you use a single quote and put it in front of something, that quotes it. It's not inside a paren. And it doesn't surround it. It's just before it. So that's right. Just bam. Right. And you could do the same thing with the foobar 310. Yep. Well, no, it has to be a single form, right?
Okay.
Quote.
So what if I did? No, that's not.
Yep. Oh. You got the list back. Now, there is something that I'm a little unsure how this works in Racket. You know, I'm not going to talk about it right now. I'll just say that in some Lisps, it is dangerous to use like literally quoted lists if you plan on modifying those lists. Which is kind of a good thing to be aware of. But it's kind of a little bit of a rabbit hole too, right? And we don't even know how to modify a list yet, so so we won't worry about it very much yet. And I'm not sure that this is the case in Racket actually anyway. I kind of think it isn't probably. But yeah, so quote can be very useful in some cases. A lot of times when you really, and one thing that quote's good for is making lists. If you don't plan on, modifying the list, it's certainly safe enough. But you can also use list to make a list, right? List makes a list, just as we did it above. And list, when you use list to make a list, you are guaranteed to get a brand new list. So,
because it creates its own environment.
Well, it's not creating an environment. It's just creating a list. There's some weird stuff around like what happens when you quote a list. That's what I said was a rabbit hole that I don't really want to get into. But it's not guaranteed. It may be that when you type in quote 345, the way that it works in many common Lisp implementations at least, is that if you type in quote 345, that always gives you the same list back. It doesn't make a new one every time. It just sort of says, okay, I'm just going to hang on to this like quote 345 list here because it seems like, this is being used and somebody might want it several times. So I'm not going to make a new one every time because that would be sort of expensive, right? I'm just going to save it. That's called interning, right? Where it just has one of them. So in a lot of common Lisp implementations, it does not make you a new list. That's why it's dangerous to modify them. Because because it modifies it everywhere because there's only one of them. But this is a rabbit hole. This is some stuff that really has to do with like the implementations of programming language that like I don't really want to go into, and we don't even know how to modify a list at this point. So, it's not a concern for us. But it is sort of this thing. There is a bit of a difference potentially between this list and that quote in terms of its behavior. But they both evaluate to the same thing, which is a list, right?
Mm-hmm.
The same value. It's just a list that contains elements. And so lists contain elements. Now, there is such a thing as the empty list. If you type in quote, open paren, close paren.
Like the quote without a paren?
No, single, I'm sorry, single quote. Just the,
Ah,
yeah, that.
gotcha.
Right. You could also do it with the full quote. You'd do open paren quote space open paren close paren close paren. You wouldn't. You know what I'm saying? You can try it out if you want, just to make sure you understand what's going on here. Yeah, it does the same thing. I mean, quote that quote form written out and then that single quote form. They're
Yeah.
syntactic sugar. They're exactly the same thing. It's just one
Yeah.
is a slightly more convenient syntax for writing it.
Got it.
Um,
It's like if you could write add, I don't know, maybe you can. Can you do that? No.
yeah, add's not a procedure, but quote is the normal way of doing it. It's just note that that single quote's not following any sort of rules that we've seen before at all about this. This isn't even like a special form. This is weird reader syntax, basically, right?
It's not the single quote's not a special form.
It doesn't come after an open paren, does it? The single quote is a special form.
Yeah.
The single quote goes beyond that, though. It's breaking all the rules. There's not even a paren before it. It's just, it's reader syntax is what it is. And you don't have to worry too much about it, okay? Just know that it's there. But know that it's breaking all the rules here, even more rules than our special forms we've seen have done. It's like,
Yeah.
it is a piece of syntax
Okay.
for the reader. So we won't worry too much about it. It's, again, that's kind of a rabbit hole at the moment. But just know that it's there. It does what it does. So...
Yep.
let's define like my list to just be the list 3, 4, 5. Right? We don't want to define list to be that because we would actually be overwriting the list procedure, which we really don't want to do.
Yeah. Find my list, and then I gotta do right.
Okay.
Cool.
Bit of a problem here, right? Because
Sorry.
it's trying to evaluate that according to the rules of evaluating scheme. And what is the rule for evaluating an open paren?
First thing that comes after it is the
Is something that should evaluate to a procedure, right?
yeah.
So what's the first thing that came after that open paren?
You're saying the first open paren?
Not the one with the define, but the one where you're trying to create the list.
Yeah, and that's is it's got it highlighted in red. Is the list? It's like
Well, it's a 3. A 3 is the first thing that came after that open paren.
oh, that's what it says. Special procedure, and it got a 3.
Right. 3 is not a procedure. So it's trying to evaluate that, right? If you typed in define, let's say you typed in define y to be like open paren plus 6, 7, you'd get 13. That's what, it evaluates the thing first.
Yep.
So you have to quote the list. We don't have to put the quote. This is what I'm saying about, hold on. This is what I'm saying about quote being very, very special. The quote doesn't get a paren before it. If you wanted to type the word quote out, you could. Okay.
Gotcha. If I wanted to quote, I'd have to put a paren, do like that.
Yeah.
But without that, that's the syntactic.
Yeah, it's just this very special syntax.
And then the 3 has to be right after the thing. Right?
For it to be a list, now you're quoting the number 3. Quote operates on a single form. So it's really important to keep in mind how many forms there are in things that you're doing. Quote operates on one form.
Which means I have to embody it within a parenthesis to be.
One expression. I mean, whether or not this is technically a form is actually technically not a form, but we won't worry about that. It's close enough to a form for our purposes. Yes, you get this list back. So this is a list, and lists, so Scheme is a dialect of Lisp. Lisp stands for List Processing Language.
Mm-hmm. Okay.
Lists are very important in Lisps and in Scheme. One of the reasons, as I already mentioned, is that Scheme programs themselves are lists. right? The program itself is a list, which means that it's very easy to write programs that create and manipulate programs. And that's something we'll eventually talk about. And it's a very powerful property, actually.
You said scheme is itself as a program is a list.
A scheme program is a list,
Gotcha.
right? Like
Right.
the things we've been writing are little programs, right? Like we're kind of writing little programs at this point when we're typing things out.
Each line is its own. I mean, yeah, for like the
Well, and the whole thing is kind of a program in terms of the environment. I mean, this gets a little bit loosey goosey, but yeah, they basically scheme programs are made up of lists basically. So when you do something like open paren lambda, space open paren x y etc., we evaluate that. But if you quoted it, you would get a list back with literally like a list with a list where the first thing in it was a lambda, right? And the second thing in it was another list with an X in it, right? And the third thing in it was a body that was a list that started with a plus and then had a form that was a list that started with an asterisk and an XY. Do you see what I'm saying?
Yep.
Like it literally is a list. So there are a number of things that operate on lists, and we talked about this last time. These are historical names. It's important to know them in case you read literature that uses them. You generally don't yourself want to use them most of the time. Kind of. It's kind of up to you, but I think a lot of people don't. But to get the first element of a list, you can apply the procedure car to it. CAR, just like the wheels on the car go round and round. So try getting the car of my list.
And then just be 3. Cool.
3. And now there's also a cdr, which is spelled CDR.
Right now. Yep.
Yeah. So car and cdr destructure lists. They take lists apart. And we're going to want to look at how to put lists together in a second. So I want to point this out that these are symmetrical, that there's a symmetry at work here that we're going to be seeing, because that's kind of important. Car and cdr are named the way that they're named for historical reasons. CAR stands for Contents Address Register, and cdr stands for Contents Decrement Register. And this is like some stuff that has to do with some weird hardware on some computer that nobody has used in 40 years. Okay. So
what's the D again? D what?
Contents Decrement Register. To decrement something is to take 1 away from it.
Okay.
If I decrement 4, I get 3, right? If I increment 4, I get 5.
Okay.
Actually, in fact...
Yeah, let's say decrement's a word I use a whole lot. Although increment I was just using that today. But onward.
Okay. So there are modern equivalents for these, which are generally to be preferred, I think, which are first and rest.
Got it.
So if you do first...
Oh, and it's in I could do it in this one. In scheme. Yeah, okay. And so rest and cdr, just take away the first one, give you the rest, everything else. If I had 10, it would give me the last 9 items in the list.
Yeah, and so let's note something about this, okay? Which is first and rest don't return the same type of thing, really. I mean, they could, but
yeah.
First is returning whatever kinds of things are in the list, right? In this case, a number. This is a list of numbers, so first is going to get you a number. Rest is going to get you a list, and it doesn't matter what kinds of things are in the list. Rest always gives you a list. Okay.
And so even if the list only has 1 value or possibly even no I mean, I guess it
It's
could
an
be.
error. It's an error if it has no values. So try taking rest from the empty list. Do you remember how to type the empty list?
Yeah. So, oh, so I can do. um, uh,
Yep. So that's an error. And it's sort of telling you there what the contract is, what the error is. So it's saying that it wants this thing to, the and means that it wants both of these things to be true. So it wants
uh-huh.
it to be a list, which it is true. The empty list is a list. And do you see that not see empty? It wants it to not be empty. This is kind of how to read these error messages, right?
Okay.
It's
Yep.
expecting that you get something that is a list and that is not empty.
Mm-hmm.
So that's an error. However, if you give it a list with one item in it, like just the list containing one.
What are we doing? Rest. Sorry. It's, um,
Yeah.
oh,
You mentioned the
all right.
empty list, right? Because that's you
Took the one away, and
you
what's
took the one
left?
away, and what's left is there. So now Scheme actually does. I think that actually maybe the standard even guarantees that Scheme will have name for like second, third, fourth, fifth, sixth, and I think it guarantees that it will have them up to like 9 or 10 or
Yeah.
something. So you can ask for second, third, and that will get you an item, right? Second is very different from rest, right? But what if you didn't have second? Can you get the second item of a list just using first and rest?
Hmm. Okay. Yeah. Right. We
So
were
get the
working.
4 out of 3 out of my list. Get the 4 out of
Right.
my list without using second.
Yeah. Yeah. Let me think about this for a second. I'm gonna wanna. Um. Um. Okay. So get to the four. So if I go to, I want the car of the cooter in this case because there's three. I want the second. Well, I guess it'd be in any list if you want the second one. You want the
That's right.
car of the cooter.
You want the car of the cooter or you want the first of the rest. Yeah.
Yeah. Okay. So and then
And I'll show you a neat little trick, which we did discuss briefly last time, but
do I just do it like this?
nope. Let's think about what we're doing. Car and cooter are both procedures.
Okay. Right. Give me the car. So I'm gonna cooter my list and then give you the car of that.
And there you
Nice.
go. Now, there is a weird little trick that you can use. Now, you could also write this, and you usually should write this in terms of first and rest and not car and cooter, right?
Okay.
So it would be the first of the rest of the list.
Um, yeah. Got
There is a little trick you can use, by the way, if you are using the car and cooters, which is that there are you can combine them. So you can actually type in CADR, my list, and that gets you the car of the cooter. It's pronounced catter.
And I don't need to.
Yeah, it's one. It's a single procedure,
Right.
and this is defined up to quite a lot of things. You could get the cadaditor of a list, right, which would be the car of the cooter of the cooter of the car of the cooter of a list.
Hey, good. Yeah. If you got a long list, it can have a lot
Well,
like that.
it would
That
it,
it, oh, that's I heard that song. What is that? It was like a Billie Holiday song.
right. It
Back.
would actually have to be not only a long list but nested lists because you would be getting the car, yeah, of
Yeah.
something, right, which would actually be an element of the list, and then taking the cooter from that. So that would have to be a list within a list because lists can have lists inside them, right?
Mm-hmm.
Lists can contain most kinds of things. So
Mm-hmm. Okay.
so here, just to kind of like drive home a couple of points about evaluation here, make a list that contains the symbols plus and times, and give it like call it define it. Be like define my ops because they're both kind of operators. There'll just be a list that contains those two symbols.
And what do we say?
Now, so try typing in my ops and see what you get. So you get the symbols. Now, let me ask you something. How would
Uh,
you go? This is all right. So this is actually some really interesting stuff here. How would you go about? How would you go about making a list that contained the procedures that they're bound to, right? Because note that those symbols are not the same thing as
as the procedure of multiplication or the procedure of.
right. The procedures are a little bit different because there's some subtle stuff here that's important to understand, and this is actually a pretty good way of getting at it.
Because it's just within this list of my ops, they're just symbols that aren't
Those are
really
symbols because quote stops evaluation. It stops
right.
evaluation of everything. If you have like nested lists in there, nothing in the nested lists is going to get evaluated. Like once you see that quote, it's like bang, no evaluation happens past that point to the form that you're quoting.
Mm.
Right? It's just like that's that. So you can't use quote to do that really, right? Because
Can't.
you have no way of referring to those procedures directly, right? You have to refer to them indirectly through those symbols, right? But you could use the list function to do it. What happens if you type in list and then a times into plus? Try that out. Okay, you do need the open paren though. List is a procedure.
You're saying without just
Yeah, just the symbols, right? Remember how list works. It just takes you just give it arguments, right?
okay, yeah. There we go.
Right. So note that you got a different thing back here, right? But you can't really use the quote because you have no way of typing like I don't know. I don't think you can just type in that sharp open bracket procedure colon times, right? That's not a thing. That's how it prints it, but it's not something. I don't think it can read it. I could be wrong about that, but I don't think it can. Anyway, you wouldn't really want to do that. So note that you got two slightly different things back there. It is interesting though. You can use them in the same way. Like, let's say that you didn't have like multiplication available to you in the environment, or let's say you just didn't want to use that symbol from, yeah. How would you? Well, okay, taking my ops. I guess this does use the binding from the environment, but like taking my ops, can you multiply? I'll just tell you what to type in, you know,
Okay.
because it's just going to be too hard to try to like do this Socratically, I think. But if you type in like open paren, whoops, well no, just open paren. Now another open paren. First my ops. First my ops. You want to get the
Oh.
first thing in it, right?
Okay.
First my ops. Close the paren. Now space 6 7, right? Space 6 space 7. Yep. Close the parens, right? Hit return. Oh, what happened here? Oh, okay. All right. I guess you cannot. Huh. Actually, kind of surprises me a little bit. Okay. Try doing it to the list with times and plus, though. I'm actually a little bit. Oh, right. Right. The quote quotes everything inside the list. Right. This is an important point and a subtlety that I sort of forgot about here a little bit. So you do need the procedures. So
You mean this up
let's
here?
redefine my ops to be the thing where you use the list. Right.
Oh,
Yeah. Okay. And now try doing that first my ops 6 7. Uh, yeah, yeah, looks good, right? And
Oh, so it did read. It went to the first. Now, how does it? Is that's what you're telling it? Do take the first item on the list.
well, so let's think about what happened because this is all rules that you've seen before, right? This is just what I mean about literally going through and applying the rules. So, what is that? That line starts with a parenthesis. What does that parenthesis mean?
Means evaluate the next thing in here as a procedure.
Evaluate the next thing in here, right? Try to treat what it evaluates to as a procedure and apply it to arguments. So, what's the next thing that it sees?
It sees that another parentheses, which means that whatever within this parentheses is the proceed is.
A procedure, right? So it sees this form, first myops, and what does first myops evaluate to?
Well, I guess I don't remember the. Oh no, the first is up there. Oh Jesus Christ, dude!
That's car of myops.
I am tired. First and rest. It's when sometimes you look at something like, wait, what is it? Word? Yeah, no, first. I got it now.
Right. So it takes the first thing in myops. Well, what's the first thing in myops?
It's a multiple. It's a procedure
It's a
itself.
procedure. It's a procedure, and so it says okay. So first myops does evaluate to a procedure, right?
Yeah.
It gets the first thing out of this list, and that's a procedure. So you can store procedures around, and then like pull them out of stuff and do stuff with them, right? And this can actually be very useful. You can do some kind of slick things with this.
Yeah. And yeah, you're storing it so that it's there, and you can just. I'm not going to worry too much about like how it gets applied. I'm kind of like, lists. Like I'm.
It's the same thing that happened when you type an open paren and a star, right? The star happens to evaluate to the multiplication procedure, right? That's just because that's what it's bound to in the environment. But the important thing is sort of the procedure. The procedure is what gets applied to the arguments, right? That's why we can do the thing where we open a paren and then we type in a lambda, and then we apply that to arguments, right? Because the lambda expression evaluates to a procedure.
So is the terminology on this line up above that evaluated or that resulted in the 42, or I guess that's correct to say it's evaluated to 42, right? The 6 and the 7 are the arguments in there?
They are the arguments.
Okay. Cool. Yeah. I'm still a little congested. This thing has been lingering.
That's too bad, man. Like, was it just like a cold or?
Yeah. I did test at one point for the COVID because I was, whenever that was, we went somewhere. Can't even remember anymore. But I went down to Bennington stuff. But anyways.
Alrighty, Benning Vegas. I don't think that really applies.
Yeah, I don't know. You haven't been there in a while.
People talk. I used to know somebody in particular who used to talk about Brattle Vegas. Which I think that for that to make any sense, you really do have to live in like the northern part of the Pioneer Valley, which he I guess had at one point. So it's the big city. It's the big city if you happen to come from Turner's Falls. I don't know. They had a really interesting, colorful murder a few years ago, but that's going down a rabbit hole. But involving the co-op, actually. It's a rather shattering thing for the Brattleboro co-op people, I think.
In Brattleboro. I thought you were saying in Turner Falls.
No, not Turner's Falls. Not Turner's Falls.
Turner.
Yeah.
No, I guess I would have thought it.
Yeah. No, it was kind of a big deal, actually, for a little while. Because it involved the co-op, right? It was like people who didn't expect, like, I don't know.
Yeah.
But, weird stuff happens.
Keeps happening again, too.
There's a company I sometimes buy things from that, like, just ceased operations a while ago, but they were still taking orders for quite a while, and people weren't getting stuff from them. And then eventually somebody did some digging and discovered that, like, the guy who owned the company had committed a murder-suicide.
Oh, shit.
And, like, their systems were still online, and so orders were still being taken, but nothing was getting shipped. Because there were a whole bunch of people that weren't getting orders, and they're, like, posting places and stuff. Like, why am I not getting orders from this place? And then it was like somebody actually went and, like, looked up records and looked up newspaper records, and it was like, oh, wow. I don't know. Stuff does happen. Anyway, that's a little dark for, our programming stream. So we'll return to lighter subjects like applying procedures to arguments. So this is kind of cool, but like we want to talk a little bit about like constructing lists, about putting them together, because we have this way of making a list just by giving it a whole bunch of arguments, right? You just have list, and then you apply the procedure list to a bunch of things, and it puts them into a list in that order, right? That's what the list procedure does, right? And we also have this quoted thing, but what happened up here, which I even spaced out about, I mean, God, that I shouldn't do that. That's like I am tired too. So one of the things about quoting things is that it stops all evaluation and it quotes everything all the way down through. And here's the thing, you cannot apply. So when you had defined myops to be that quoted list with the times and the plus, and then you tried to do first myops and you got that error, right? This is a subtle thing here that happened, and it is a good thing to understand this subtlety, okay? Quote stops all evaluation, and it gives you back essentially a quoted symbol, right? Like that
Yeah,
thing in the list that you get back, it's not just that the list is quoted, it's that the symbols within it essentially are quoted. Like everything has been stopped there, right?
like a nerd. Yeah.
So you cannot apply the symbol star to arguments. The symbol star is not a procedure.
It's just a symbol.
It's just a
It's
symbol. So if you type an open parens here, let's make happen what happened there, just to make this very explicit. Type an open parens. Now type in like single quote star. And then 6 and 7, right? Space 6, space 7.
hmm. It's just going to give me back the
It's going to give
star.
you an error.
Oh,
It's going to
because
give you the
it's
same error. You are trying to
not.
apply a symbol to arguments, and you cannot do that. You have to
Yeah.
apply a procedure to arguments. Now, when we normally type in a times 6, 7, the rule for that is that it evaluates, the symbol and that. But when you have a quoted symbol there, right, when you're saying don't evaluate this,
Yeah.
right? So it's just sort of important to understand that's what happened with that quoted list. So in that case, we really do have to use the list thing to actually put the procedures into a list. There are other ways of making lists though, which is what I want to get to, which is we can construct lists. So I'm a little bit wondering about how to approach this. This will finish us up for the evening, I think.
hmm
But this is a pretty important thing, and what it is the symmetrical inverse of first and rest, right? We use first and rest to take lists apart.
Yep.
There is a symmetrical set of functions that sort of puts them together, really asymmetrical function, which is cons, cons. And
Okay.
so cons does not just create lists. Cons creates con cells, which is sort of, I don't want to talk too deeply about them yet. We will talk about them. But cons takes two arguments, okay?
Okay.
And if you just give cons 3 and 4, why don't you try applying the argument cons, applying the procedure cons to the arguments 3 and 4, right? Cons 3 to 4. You don't get back a list. You get back what's called a dotted pair. And
Okay. Yep.
I don't want to talk too much about dotted pairs quite yet, except to note that this is not a list in the normal sense of the word list, okay? It has a lot of similarities to lists, but it is not a list. And we'll talk about dotted pairs later. They're quite useful for some things. The deal with cons, though, is that if you cons something onto a list, you get a new list back with that thing const in the at the head of the old list. So try consing 3 to the empty list, or actually cons 4 to the empty list. You do need the quote there because it's going to try to yeah. Or you could type in list. List by itself with no arguments should give you, pretty sure in Racket that will give you an empty list as well. But that's fine, right?
Okay. So I need because it won't know it's even. What did I do before? I just put in the thing, which is. Oh, I thought that. Okay. So
Now try consing 3 to the result of consing 4 to the empty list. Consing 4 to the empty list. So you're going to have two applications of cons here. That's right.
okay.
Okay. So when you cons something onto something that is a list, you get back a new list where the tail of that list, the coulter of that list, is the second argument that you gave to cons.
Mm-hmm.
And the car of that list is the first argument that you gave to cons. So note that that's how that worked. You got back a list, so you gave cons 2 arguments. You gave it 3, and then you basically gave it a list containing 4, right? Like, we can make this a little clearer by typing in cons 3 and then just quote a list containing 4.
Yep. Yep.
Okay.
And it's that same thing again where it goes to it constructs the list first. I mean, like just conceptually, I made this out. So then be able to put the 3 on too, because it knows.
Well, it evaluates the arguments, right?
Yeah.
When you apply a procedure to arguments, those arguments get evaluated before the procedure ever sees them.
Mm-hmm.
Okay. And we talked about this last time, and we'll probably talk about it again because we talked about short-circuiting operators like or and not and stuff, and why they have to be special forms. And we talked about if, which has to be a special form. Okay. Because it does not evaluate its arguments. But when you have a normal procedure and you apply it to arguments, those arguments get evaluated. That's the first thing that happens. So you applied cons to 2 arguments here, and the first argument was 3. So that's simple. That evaluates to 3, right?
Yep.
The second argument was this form, cons 4 to the empty list. So that got evaluated. So what cons saw, maybe you should type it out to see what happened. What that first con saw, though, was like open parens cons 3 space, and then like quote a list with 4 in it. Just, you're going to need to use quote for it.
Somewhere on the keyboard. You didn't know where it was. The fuck, dude.
I've been playing a little guitar recently for the first time in a very long time. You're reminding me this is how it feels to me playing guitar lately. Yeah, okay. So cons has these 2 arguments, okay? And let's just assume for right now that the second argument is always a list, right? Because if it's not, we get dotted pairs. And I said, I don't really want to talk about dotted pairs at the moment. Okay. But if the second argument is a list, then we're always going to get back a list. Okay. Right? Cons 4 to the empty list, we get back a list with 4 in it. Cons 3 to a list containing 4, we get back a list containing 3, 4. I really want to emphasize this is a super important point, although it's probably not clear quite yet why it is an important point, but it will become much clearer fairly soon why it's important. And it just really helps you think about what cons does, that the arguments of cons correspond to the car and the cooter of the result of the cons. Do you see that?
Arguments of cons correspond to the car and the cooter of the result of cons.
Right. So you gave cons 2 arguments, 3 and a list containing 4. The result of what cons gave you back, which is that list 3, 4, what's the car of that list?
3.
And what's the cooter of that list?
4.
No.
Cooter is what's left
Cooter is
after.
a list containing 4.
Okay, gotcha.
There's a big difference between 4 and a list that contains 4, though. And this is part of why it's important to think about it this way, so you don't get confused about those 2 things, right? Remember that car returns you whatever type of thing is in the list, right? Whatever type of thing that first thing in the list is. It just gives you the first thing in the list. So you don't know what type you're going to get back from car unless you know what's in the list. Cooter always gives you a list back, though, right?
Gotcha.
Cooter always gives you a list back. So assuming we're not making dotted pairs here, assuming that we're calling cons with a list as the last argument, as the second argument, when you call cons 3, 4, you get back a list. The car of that list is the first argument you gave to cons, and the cooter of the list you get back is the second argument that you gave to cons. It's completely symmetrical. So cons puts lists together, and car and cooter take lists apart.
Okay. Yeah, it seems pretty straightforward.
Yeah. So it is. That's an important thing. So you really want to remember that, right? That like cons is cons is sort of the inverse of car and cooter. Cons puts a car onto a cooter, essentially, right? So yeah, and I did want to. Okay, so we'll talk about one other thing really briefly. We talked about it before, but we'll talk about it again. Map. Um, so we had what is foobar? Like foobar is a function of one argument, right?
Make a note there.
We defined it earlier. I think foobar is the one that's a function of one argument. It like multiplies by 3 and adds 5 or something.
The foobar is
Yes. Yeah. Okay.
yeah.
That's an argument, you know. So this is a very sort of useful thing to be able to do. If we go down here, if you open a paren, type map, and then type in foobar, right, which is a procedure, and then you type in just make a list that contains like 4, 5, 6, 7, or whatever. Okay, but a list that contains them. Yeah.
Oh,
Well, no. Nope. The quote does not go inside the parens. Remember, it's a very special syntax. But you do
oh,
need a paren after the quote to make the list, right?
isn't that what I did?
No, you just type it 4.
Oh,
You do need the enclosing parens. And then just close up the parens and hit return. So map is a tremendously useful function, right? Map takes foobar and it makes a new list by applying foobar to each element, you know, where foobar has been applied to each corresponding element.
oh. Hey, wasn't foobar multiplied? What the hell was foobar?
Multiply by 3 and add 5.
Okay.
So here, 12 plus 3 is
Yeah.
17, right? 5 times 3 is 15 plus 5 is 20. 6 times 3, 18 plus 5, 23. Yeah, so you see it actually. It all
Oh
checks
yeah.
out.
Yep.
Okay. Now, map can work on 2 lists if you give it a function with 2 arguments. So, for instance, foo-baz, right? Foo-baz takes 2 arguments, right?
Yeah, the foobas and foobacks too.
Foo-bax, they both take,
Right.
right? Um, so if you map foo-baz and then you give it 2 lists, it does need 2 lists now, though. So like maybe 1, 2, 3, 4, and 3, 4, 5, 6. Okay, with spaces.
Boy, what's he doing?
Okay. So what it's doing is it's taking them in pairwise fashion. So first it calls foo-baz with a 1 and a 3. And then it calls foo-baz with a 2 and a 4. And then it calls it with a 3 and a 5. And then it calls it with a 4 and a 6.
How does it know how to do that?
It just does. That's how it works. It's written that way.
Yeah, that's what map. But how do I remember that's what it's?
Try doing something simpler. Try doing the same thing that you just did there, but use plus instead of foo-baz. So again, it just takes them up pairwise. It just says, okay, I'm going to take the first element of each list. I'm going to use those as the. So obviously, the number of lists that you give it has to correspond to the number of arguments that the function that you are mapping over the lists takes, right? Map is most commonly used with a single list, though. That is by far the most common application of it. Map's very, very useful. Map gets used a lot. So this is an example of a higher order function. This is a function that takes a function as an argument, a procedure, because I should be precise with my language here. Map takes a procedure as one of its arguments, right? But then it applies it.
Okay.
You could even, you could map first of my ops across a list too, right?
My ops was.
Try doing that again, because my ops just has two procedures in it, right? So if you do map, and then first of my ops, right? Or car of my ops, either way. Well, first is a procedure. Okay, but you have to close the first, right? Right? Because that's just a procedure. That's just like getting the first thing out of my ops, right?
Oh, okay. Yeah, I get it. Um,
Well, okay, but you wanted to give it to two. You wanted to give it two lists in this case. The first thing in my ops is multiplication.
Yeah.
So multiplication does work on a single number. We've seen that before. You get the number back, but
I guess what I'm confused about is how it knows, like what's this relevance of the first and the third in the list,
I'm not sure I understand what you mean by the first and the third.
First and the third number in each list. That there was, so if it's taking.
It's taking the first element from each list.
Yep. Oh, it's it's funny because the way we have our lists, I was looking at the first list and saying like, oh, it's taking the 1 and the 3 in that first list, but it's taking the first of it and then 2. I got it now. The second. See what I'm saying?
I do. Yeah. Right. No, it's matching them up. It's taking one from each for each argument.
Yeah. Now I got it.
Okay, I didn't quite understand that, but now I understand why there was some confusion there.
Yeah, it's just because actually, if instead of, because of the overlap there, 3, 4, 5, 6, if we just had 1, 2, 3, 4, and then 4, 5, 6.
4, 5, 6. Yeah, it might have made it a little clearer.
Or 5, 6, 7, 8.
Yeah.
Yeah.
And so one of the things is it'll only go until it runs out of items in one list. So try doing that again.
With the uneven
First
number.
of my ops, yeah, but don't give it the 6 on the second list. Pretty sure about this, that this is how racket works. This is typically how this works. Yeah, it has to be that way. There's no other way it could be, in fact, that would make any sense. Oh, nope. Okay. That's the other thing it can do, is throw an error. So in many programming languages, what would happen is we would just get back a list of 3 out of them. It would go, okay, 1 and 3, 2 and 4, 3 and 5. And it's like, oh, okay, but there's nothing here, so I'm just going to stop, and it would give you back 3. But okay, Racket requires you to be precise about this and says, no, the list must be the same length.
And so that last item there on the error message of procedure, that's interesting. It's telling you that the procedure, and that's kind of what, well.
That's just part of how it prints its error. It's telling you what procedure it was mapping.
Yeah.
Yeah.
Okay.
It's specific to map. That's how it prints its errors.
It would be the same thing if it's not a matter of. It would be the same thing if it had an extra. It had like a extra appendage on the second list. It's not a matter of the fact that it reads the first list first. We would also get an error message.
Yeah. Doesn't matter the order. Like one of the things, I mean, it's telling you map requires that all of the lists that it gets be
Yeah.
of the same size. That's just a requirement. It throws an error otherwise. That's not how all languages work. In many languages, you can give it different size lists, and it just stops on the shortest one, basically,
Mm.
when it comes to the end of the shortest one.
Got it.
But okay, that's the scheme rule for this. Like, I don't know. It's been a while since I've done scheme, and I have programmed at this point to some degree or another seriously in I guess like 4 different Lisps. They all have slightly different rules.
Mm.
Scheme does tend to be stricter than most other Lisps. Scheme tends to be a very strict Lisp. So I was thinking, how late do you want to go? I was thinking, for whatever reason, I was thinking it was 5 of 11 before, but no, it's 10. So I'm perfectly happy to go till 11, but it's up to you. I know you're tired.
Yeah. No. I mean, definitely at least another half an hour,
Okay.
to evaluate.
I would like to get myself a glass of water.
Yep.
So give me just one moment. I'm going to get a glass of water, and we'll be back,
Cool.
and we'll pick back up. Okay.
Good. Okay. Yeah.
Okay. Water achieved. Okay. So that's going to be a little bit of a problem. Do you see what's happening there?
Uh, let's see. I've tried to. Don't multiplication is a procedure, isn't it?
It
So,
is, but so you're giving map 3 arguments here, right?
hmm.
So let's not worry about the multi-list case of map. Let's talk about a simple map where you're mapping a procedure over a single list. Okay. In that case, map is going to have 3 forms inside it. It's going to have map, right, which is
Hmm.
a procedure. It's just the map says this is the procedure I'm applying. It's going to take
Yep.
2 arguments. The first argument is going to be a procedure, and the second argument is going to be a list. So, what's the second argument that you gave it here?
Uh, a about a value or something or a number 3.
3. Because it's that form. You have that form as the second argument, which is open paren times 3 close paren. And what's the rule when you see an open paren, right?
Apply this procedure to the next.
Right. So what happens if you just type in open paren times 3 close paren? Right. You get a 3. So you're trying to apply 3. You're trying to hand map 3 as the argument that's supposed to be a procedure. 3 is not a
Yeah.
procedure. Is what you are trying to do here to map a function that triples each of these numbers over it?
Hmm.
Okay. So this is where lambda comes in. You need to make a procedure. How do we make procedures?
I feel like I kind of why is the multiplication not the procedure?
Because the second argument you're giving to map is that entire thing, like open parens times 3 close parens. It's that entire form. And
Uh-huh.
that form gets evaluated, right? Like what happens when you type it at the REPL? It gets evaluated. Times is applied to 3. The whole thing evaluates to a 3.
Yeah, it's not like yeah.
Now, if you were in Haskell, this would be a little bit different, actually. There are languages that allow for something called point-free programming. I don't think we want to get into that, though, to be perfectly honest with you right now. It's
Yeah.
kind of funny that it's kind of funny. I mean, it kind of tells you that point-free programming is more intuitive than some people would give it credit for, because many people find it pretty unintuitive. But yeah, you can't do that in Scheme. You need something that evaluates to a procedure. It could be a procedure because procedures themselves evaluate to themselves, right? It could be a symbol that is bound to a procedure because symbols evaluate to whatever they're bound to.
Isn't that isn't that what the asterisk is? Is a symbol that evaluates
It
to a procedure.
is, but the second argument you gave to map is that entire form. Open parens times 3 close parens. So that form is sort of governed by the open paren, which says, look at the second thing after the open paren, right? That's the rule for evaluating a form.
Mm-hmm.
Right? And it's literally exactly what happened when you just typed it at the REPL, right? Exactly the same thing happened. That form got evaluated. It's that second form that you handed to map. It gets evaluated, and after it's been evaluated, what it evaluated to is passed to map. So map never sees the asterisk, right? At all.
Yeah.
It only sees the 3. Is that clear?
I think so. Yeah. I mean, and 3 in and of itself is not a procedure.
Right.
So yeah,
Yeah. So it just blows up. However, you can do what you want to do with a lambda. Why don't you give it a try?
that's a procedure. Oh boy, I'm going to need a lot of repetitions.
So what is it that you're trying to create right now?
Well,
Let's
I'm
just think
trying
about
to
it conceptually, like at the
right.
highest level without talking about implementation details. You want to make a procedure that does what?
I want a procedure that triples whatever items in the list I give it.
Well, probably not in the list. It's probably just going, you're not going to give it a list. You're going to give it a single item, right? But yes, it will be an argument in the argument list.
It'll be an
Right.
argument.
Well, you're not going to hand it a list as an argument. You're going to hand it a number as an argument. Right. But I see what you're saying. You're using the word list here because you want to think about this argument list that you're writing right here. But
Mm-hmm.
at a high conceptual level, this is just a procedure that takes a number and triples it.
Yeah. Okay.
And so what you said is takes a number in the list I give it. And I just want to be very precise about what we're saying here because precision kind of matters here. You're not going to give the procedure a list. You're going to give the procedure an argument.
Mm-hmm.
The way that you tell it that, though, is to write an argument list, which is where I think the list is coming in and kind of confusing things a little bit, if you see what I'm saying. So how many arguments does this function take?
One.
That's right. Yeah. Okay. So let's go back and think about lambda. So lambda has 3 parts. It's got the lambda, and then it has the argument list, and then it has the body, right? What is the argument list?
The argument list is. You mean in this specific example?
In lambda, just in lambda in general.
The argument list is it's the generalized thing that you want to apply to the body.
It's the list of arguments. It's a list of symbols that you want bound to the values of the arguments that got passed in.
A list of symbols that you want bound to the
values of the arguments that you passed in.
Values, the other ones.
While the body's being evaluated.
Mm-hmm.
So how many arguments do we have? Do we want to have for this function?
I think it's just one. I mean, okay. We're just going to...
What do we want to call it?
Right, it could be called anything, yeah.
It could be called anything. X is probably fine, though, for this kind of little numerical procedure. So you would just put an X in and then close the argument list.
Yep.
And then you would type out the body.
Where... well, and so it'll know that X is, so the next thing, since the body is bound
Yep.
to the arc,
But be a little careful here. So you need to multiply 3 by x. Yeah.
multiply 3 by, it's not going to just,
No, it's not going to just. This is kind of the point. The body gets evaluated. You have to use the variables in the body, you have to actually refer to them.
I don't know, that doesn't seem
Yep.
right.
That's fine. That is actually indeed exactly right. And now close up your parens. Well, don't close up the map because you still want a map, right? So that's your first argument to the map. That is something that will evaluate to a procedure. And we'll take a look at it again in a second, but let's just finish up doing the map because we should really like get the lambda thing like tied down. Yeah, there you go. But let's talk about this lambda again, right? Like, let's why don't you bind that lambda to a name, like bind it to times 3? Yeah, you don't have to. You're not applying it to anything. You're just, yeah, defining times 3. So let's apply times 3 to 5, for instance.
Whoops. What were we doing? We're applying times 3 to 5.
Okay, but how do you apply it? How do you apply a procedure to arguments? Yeah. Okay. So let's think about what's actually happening here. Because this is, again, what I was saying before. Like, let's just go over it again because, like, it'll stick. You know, it's just a matter of, like you were saying, it's a matter of repetitions. You just have to see it a few times. But there is a logic to this, which is that body, when you have this lambda and then you have this argument list and then you have this body, when you apply the lambda to some arguments, it's as if you were to type in the body, but replace each argument wherever you see one of these symbols that's part of your argument list, replace it with the value that got passed in for that corresponding argument, right?
Okay, right.
So you type in times. It's as if you typed in times x3 and you replace the x with the 5.
Yeah. I know. I don't know why I'm having such a hard time.
I mean, it's conceptually kind of hard. People aren't used to thinking about things in this kind of an abstract way.
It's like, you know what it is? I feel like I'm just kind of grabbing at the form, too. You know what I mean? Like, I can say, like, oh, yeah, X. Like, I'm going to say X, and then this is where the X gets applied. And when we apply this lambda, and I know my terminology is...
When you apply the procedure it creates, yep.
Yeah, apply the procedure that the lambda creates, then you know the value that you apply it to will be you know, substituted in for that X.
Or, well, that's exactly right, but it is substituted in for the X. It is not just sort of like, yeah, you can't just do times 3. It is not, yeah. You do have to refer to it, right? There's this kind of there's a little bit of indirection here, right? In the sense that the argument list is just there to bind names to values so that you can refer to them in the body. Because I think
Hmm.
it might help to think about this in a really conceptual way. Like, why are we using lambda here, right? Because we want to generalize the concept of multiplying something by 3.
Hmm.
Okay. We need to refer to the something somehow, though, right?
Yep.
And that's kind of what the lambda is allowing us to do is say, look, they're going to pass us an argument. We don't know what that argument is going to be yet, but I need to write out something with the right shape times argument, argument, right? Because that's, if you want to multiply two things together, that's how you do it. It's like times, thing, thing. So
Yep.
I know one of the things is going to be 3, right? That's just a constant.
Yeah, because that's the purpose. Well, in this case.
Yeah, that's
Yeah.
what we're doing, right? But what's the second thing, right? I need to write this out. So I need something to put there that later on is going to get filled in. But I have no way of knowing what that's going to be because that's up to the user, who calls this function. Could be me, could be somebody else that's calling my code, right? They're going to put in some number. It could be 11, it could be 15, it could be 22. I don't know what it's going to be. I need a way to refer to it right now, though, because I need this multiplication to be like times this by this.
Yeah.
And so that's the whole purpose here. And so
Yep.
when you really think about it from the point of view of why we're using lambda, why it exists, it makes it much clearer what the parts are, right? Because
Mhm.
first we just need this list of things that tells it, like, okay, somebody passes, because remember, this could be more than one argument. This could be 3 arguments. Let's say that you had, I mean, this is silly because plus already does this in Scheme,
Yeah.
but like, let's write a procedure that sums 3 numbers, okay? You could name it sum 3 numbers, right? And we'll write it using a lambda, not the defined shorthand, right? Define like sum 3, I guess.
Gotcha.
Yeah, you can't define 3. It won't let you do that. It's like nope, three
No,
is three. 3 is 3.
no, I know I was going to put 3 numbers, but it's some threes. But,
Uh can you start a symbol with 3 numbers in with a digit? I don't think you can do that. Do that. Scheme's pretty forgiving. No, you can actually. Gosh, yeah. Okay.
yeah.
I always forget the rules for what's a legal name. Very few programming languages would allow you to do that, but Scheme will.
So would it just be, um,
Well, hang on. These 3 numbers, there's going to be 3 of them, right? We have 3 arguments. Okay, so go ahead.
uh,
Okay, so this is a procedure, but I don't think it's not the one that I intended it because I meant 3 different numbers. Like it could sum 4, 5, and 6, for instance.
oh,
This
gotcha.
triples a number. This triples a single number. But what I want to do
Yeah.
is something that can take any 3 different numbers and add them together.
Oh, yeah. So you,
Right. Yep.
and,
Give it a try.
and then I see that. Um, okay.
Okay.
Yeah.
So again, I mean, you can see, and it's perhaps, I mean, the thing is, addition's commutative and stuff, so order doesn't matter. You kind of have to trust that, in fact, it is doing it in a particular order. If this were something where order mattered, of course, right, then, right, I mean, addition's commutative. So
Yeah.
it did slightly different things there, but the result you get back is the same. You can't really see it from the result. If we were doing something a little bit different where order mattered, like, for instance, adding the result of subtracting one of them from the others or something, right? Where because subtraction order does tend to matter a little more. The order would matter. But so in this case, it's 3 arguments, and it has to know. I mean, again, because the commutativity here, it doesn't actually matter, but it has to know which one to put in the right place, right? You need to be able to refer to each of these arguments by name in the body, right?
Mm-hmm.
You want to generalize a procedure, so you want to write out a body. If you knew what the thing, if nothing ever varied, right? If it was always constants, if you always wanted to add 2, 3, 1 together, you could just type plus 2, 3, 1, right?
Mm-hmm.
You wouldn't need to write a lambda if you knew what these things were. There would be no reason to do it, right? There'd be no reason
Yeah.
to have a procedure. You would just literally type out the operation that you wanted. What lambda allows you to do is to type out the operation you want with placeholders. And then
Mm-hmm.
later on, those placeholders get filled in by the arguments that get passed in. But that means that you have to have a way of making the arguments that you pass in, of getting that correspondence made between them and between the placeholders, right? Between them and the placeholders, these values and the placeholders. And that's what the argument list is there for. It says, the first argument that I get passed in, I want you to bind it to X. And the
Mm-hmm.
second argument that you get passed in, I
Right.
want you to bind it to Y. And the third argument, I want you to bind it to Z. And then, so then when you go to type the body, you have these things that you can use as placeholders.
Uh-huh. Right. And then, yeah, so, right, when you're applying sum 3 as defined, and then, in reverse, the first, what was I going to say? Then you're binding the values you give in relation to the argument list to the procedure into that is in the body.
Well, you're binding the names in the argument list to the values of the arguments in the environment in which the body will be evaluated. Okay? Does that make sense?
Yeah.
The body is going to be evaluated within an environment, right? If you type in plus XYZ right here at the REPL, it will blow up right now. Because
Yeah.
in the top level environment, the only one of those three names that's bound to anything is Y, right? We happen to have defined Y to be something earlier on. So Y is
Right.
actually bound, but X is not and Z is not. So it will blow up, right? When you type in something plus XYZ, it wants to be able to look, it needs to evaluate those symbols. And so it's going to look in an environment for bindings for those symbols. There's going to be some environment that you are evaluating things in. If you type it at the REPL, it's the top level. So when you make a lambda, what you're doing is you're saying, evaluate this body within an environment where the names in the argument list have been bound to the values passed as arguments. That's a really pretty succinct way of pretty much saying what lambda actually does. That's the purpose of lambda in a lot of ways, is to say, I want to evaluate this body, but I want you to create this environment for me with these bindings in it.
Mm-hmm. Mm-hmm.
And there's just this direct correspondence. You can see the shape of it. If you take the sum 3 out of, let's look at this application of sum 3 to 2, 3, 1.
Yep.
If you take the sum 3 out of it, right, and just look at 2, 3, 1 and treat that as a list.
Yep.
Now look at the argument list. You can see that it's exactly the same shape. Like you can draw a line from X to 2 and Y to 3 and Z to 1. You could stack them up on top of each other and just draw lines.
Mm-hmm.
Those bindings get created, and they get created in an environment in which the body gets evaluated.
Right. Yep.
And that's the purpose of it. It's so that you have those placeholders there. You need those bindings because you need a way when you type in, okay, plus XYZ, you want to add these three things together. But you need a way to refer to each of those things unambiguously.
Yeah. And to have some kind of procedure of like what you want to do with the.
Well, what you want to do is the body. The body is what you want to do. You want to add these three things together, right?
Yeah, and I can see how you could have multiple procedures within a given body of a lambda.
Well, okay, the lambda evaluates to one procedure. The body is just some code that gets executed, right? For instance, you don't need procedures in there. And this was something I actually kind of wanted to mention earlier, and we didn't. Like, let's write a really simple lambda that takes no arguments and returns 5. You can have an empty argument list, right? Um,
Okay.
but like define 5, right? Like just like open a paren, type in define, and then spell out 5, Five. And I hope we're not overwriting something in the scheme environment, but probably not. And then write a lambda with an empty argument list. Space, and now just type 5. Note that the body does not have to begin with a parenthesis. It usually does because we're usually wanting to apply some procedure. But you can just put a 5 there. And they'll close up. Yeah, you do need to close one more set of parens. Okay, try calling 5 now. You do need, yeah. Now you're evaluating the symbol, but apply it to no arguments because it takes no arguments. Right?
Uh-huh.
Now this is a stupid function. Really, it's very rare that you're going to want to like write a procedure that always returns 5. There are actually some reasons you might want to in some cases. There are certainly reasons to create one. Whether or not there's ever a particularly good reason to write one at the REPL is another question. There are also easier ways to do it than
But there's not. But the scheme doesn't. Yeah, it has to. It doesn't understand without it being defined.
Right. We could have called that anything. We could have called it. You know, if it were my colleague Brian, he probably would have called it Blopty Blue or something like that. He has his own inventive equivalence of foobar. I think Blue de Blah actually. Blue de Blah comes up a lot. But yeah, right. So, but again, let's look at what's happening there. It's the body gets evaluated, right? And it gets evaluated in a particular argument with some bindings. In this case, we don't care, right? Like we didn't bind anything here in the lambda, but the lambda still works. It's just a constant function. It returns 5 because that's the body. It just evaluates the body. It's the same thing when you type in plus XYZ. It just evaluates that body plus XYZ. It just says plus XYZ. But now it's not just a 5. We have some symbols in there. And so we want those symbols to refer to the values people passed in as arguments, right? Somebody passed in a 2 and a 3 and a 1. So we want the X to refer to 2. We want the Y to refer to 3. We want the Z to refer to 1. Well, how do like symbols refer to things? Well, through bindings in an environment, right? They're bound to values. We certainly don't want this escaping out of the lambda, right? We don't want the fact that X was bound to 2 or Y was bound to 3 or Z was bound to 1. We don't want this having any consequences anywhere else. We just want this to be true while we're evaluating the body. And so that's what the lambda does. It creates this environment to bind these symbols, these names in the argument list to these values that get passed in as arguments. So it creates that environment and then it evaluates the body. And the body's just like plus XYZ. And that's all it is. Just like the body here is 5. It's just 5. But that's the body, right? Does that make sense?
Yeah, it does. Yeah, and I know it's amazing how, and it is somewhat like on the terminology, like the binding and evaluation, the body. I mean, definitely the argument list and the body, and the order of those things, and how the argument list is then what gets called when you try to.
Well, the argument list doesn't get called. The procedure is called, right? The argument list is just sort of there to make the correspondence. The argument list is there to specify what names are going to be bound to the values passed in as arguments, right? But the argument list is not called. The procedure itself is called. We call the whole procedure that lambda returns, right?
Got it.
And when we do that, the body is evaluated. But it is evaluated. I mean, I kind of am saying it like kind of over and over again, but I will say it again because it really is like it's pretty much what's going on, which is that when you apply this procedure created by the lambda to some arguments, what happens is it is as if you just, wherever you did this, you evaluated the body that's inside that lambda within an environment where the names in the argument lists had been bound to the values passed as arguments And the order is the same between the argument list and the arguments that got passed in, right? So
So
you can
yeah, the values that pass as arguments and is our 3 2 3 1.
2, 3, 1. And you can look, and it's that thing where if you were to like take the sum 3 out of there and then just take the rest of that list, right? You have a list, sum 3, 2, 3, 1. That's sort of what that procedure call looks like, right? I was saying scheme code is just lists, right? So if you take the procedure name out of there, if you take basically the cooter of that list, which is just the list 2, 3, 1, if you were to write it underneath the argument list of the lambda, right? You would see that the x stacked on top of the 1, the y stacked on top of the 2, the z stacked on top of the 3. And so you could just draw these little arrows down to them showing what the bindings were, what values these names in the argument list were being bound to.
Yep. Yep.
Now, let's note something about this, because we talked about this a little last time, but we'll talk about it again. We'll talk about free variables. Which is, note that we talked last time a little bit about how environments nest like Kachinka dolls.
Mm-hmm.
So when you wrote sum 3, why, and then you called it with 1, 2, 3, y got bound to 2. Right? So you got 1 plus 2 plus 3. Well, yeah, that first time that you called it, because you called it a couple of times. Then you got bound to 3 in the second one. Let's note that y is already bound in the enclosing environment to 10. And that environment exists even when that body is being evaluated, but the innermost environment takes precedence, right? Because they nest like Kachinka dolls. And the outermost environment is the top level environment.
Mm-hmm.
And saying top level is a little bit like it would be more precise to say the enclosing, the outmost environment, right? Because it actually encloses. But we can write a function. Let's write a lambda called add to y that adds a single argument to the y in the enclosing environment. Does that make sense?
Okay, let me actually have you see. It's called add to y.
2 as in to. Yeah. Usually you would use like minus signs between the words in Scheme, typically. This could pretty easily be confused for add toy.
Yeah.
Which sounds like fun, but
Yes.
yeah, so I would put a minus sign between the add and the 2 as well. Yeah. This is sort of to make this nice. That's the Scheme convention. That's illegal in most languages, by the way, because most languages can't tell the difference between that and subtraction.
Oh, interesting. Yeah. What are we doing? Doing a lambda with what?
A lambda of one argument, x, right? And then make the body plus xy.
Wait. Oh, so now since there's no y, it thinks of y as 10.
Right. It will keep looking out through the environment. So try adding that to...
Yeah. Y. And now it's going to think of this. 1, 2, 15, hopefully.
Yeah.
Okay.
Now, define y to be 8 now. And try applying add to y to 5 again.
Okay.
Okay.
Yeah.
So y is
most recent. Yeah, I guess anytime.
It's not sort of most recent, but it's like whatever it currently is, right?
Uh-huh.
It's not recent. It's not in the past. It's what it is at the current moment, right? When we do define has a side effect, right? Define actually changes bindings within the enclosing environment, within the top level environment. So you change it, meaning that it currently is that. So it goes and it looks. It goes and it looks at the environment and it says, what's the value here?
Mm-hmm.
We'll talk about closures later on.
So it doesn't mean like the 10 is gone. The y is 10. Like never really whatever.
We
Yeah.
overrode it. Yeah, we overrode it. It is gone. Now we'll talk about closures later on, and we'll talk about things being able to carry around environments with them. Procedures do carry around the environment they were defined in, but it isn't a snapshot of the environment they were defined in. It's the actual environment.
What I'm not. What was carry around? You're saying?
Well, we'll talk about closures later.
Yeah.
This becomes quite important in. There are some very interesting things you can do with this. And we did look at them very briefly, I think, last time. I think that was the last thing we were looking at, but we won't. I don't think we'll get back to looking at that tonight.
Yeah. I was
But
thinking.
mhm.
I was thinking. Some of this. I mean, I made a couple notes and stuff, but I wonder, like, it's some of it I can go back and look at and like, oh yeah, okay, I kind of. But I also think it might be helpful to. Are these sessions recorded? Like, what's the?
Yes,
Can I go?
they're on YouTube.
That's what I thought. So yeah.
I'll
So,
give you a link. I'll give you a link in Discord
right,
to where there's a
cool.
list of them. They are pretty long, but you can like put them on double speed and you can jump
Yeah.
around in them, and then you can just go back and look at stuff.
That's the thing. That if I come back to it in 2 or 3 days, I'll remember. I remember enough that I'd be like, okay, I want to go back to that part and that sort of
Yeah,
thing.
the other thing is pretty soon we'll get to a point where you'll be able to write some sort of simple stuff. It won't be tremendously time consuming. And I think it would be very helpful for you to sit down and try to rate some things on your own, some very simple stuff.
Mm-hmm.
And also, because the thing is, I'm kind of here and I'm prompting you. I'm like, well, okay, that happened because
Right.
of this, that happened because of this. It can be valuable, although extremely frustrating. I am going to tell you, programming can be very frustrating, especially at first. Where you hit
Yeah.
something and it doesn't work and you don't know why.
Thanks.
And this is something you have to practice for because it's something that I've noted. It's a marker of the experience of programmers that, especially fairly new programmers, and this applies to people who are working professionally too,
Mm-hmm.
have a tendency to hit walls and throw up their hands.
Yeah.
And part of being like, if you're going, I don't know that you have a lot of plans to be a serious professional programmer, but I will admit that I have some hope that you might decide that you like doing this. You might decide, this is something I might do. Obviously, if you did want to be a professional programmer, you'd have to put more than 3 hours a week into learning how to do it, right? This is sort of dipping your toes in to see what you think of it. And,
Right.
maybe you just gain some insight into some stuff and it's kind of fun and we get to hang out
Yeah.
and that's cool. Either way is fine. But should you decide that you want to, or not just be a professional programmer, there are some things you can do with programming that are useful,
Yeah.
even if you're not like, well, I go work for a company and like write
Right.
databases, right? The
Yeah.
thing about it is that a skill that you have to acquire is understanding that nobody is coming to rescue you, I
Yeah.
guess, right? Like, you just need grit at a certain point, which is you hit walls, and if you're a professional, you have to surmount these walls,
Mm-hmm.
and it can just be like you have no idea of how to proceed. You're like, I'm literally at a complete dead end. You have to find some finger hold, some way of trying to make progress on the problem and just keep like trying to find ways of solving it. And that is something that you really have to build up as a skill. It kind of takes years to really mature into somebody who's truly good at that. Like,
Yeah.
you know,
Because I can see how, like, when you're just doing short lines like this, and you're like, well, I know that this is close to the thing. You can basically, monkey Shakespeare on the thing. You know what I mean? Because you are going to get your sentence, and they'll be like, okay, that worked, and then maybe look at it and stuff like that. But if the more complicated it gets, it's not like you can just start throwing stuff at it and hope that it works. Why?
no, there are some cases where you can. There's a guy named Jim Blinn who's a fairly famous graphics programmer, and of course, since I am in some ways a graphics programmer, I kind of like this rings true for me. But he said, the important thing about graphics programming is you have to make an even number of sign errors.
Even number of sign errors. I don't
Yeah,
know sign well enough to.
not sign as in like the trigonometric function, just sign as in negative or positive. So if you're
Oh.
multiplying numbers together, right? And you
Mm-hmm.
multiply 3 times 4, you get a positive result, right? You get 12.
Yep.
If you multiply negative 3 by 4 or 3 by negative 4, you get negative 12.
Mm-hmm.
But if you multiply negative 3 by negative 4, you get 12 again, right?
Yep.
So if you have a number that's negative in a chain of numbers that you're multiplying together when it should be positive,
Yeah.
that's a sign error and you get a number of the wrong sign. That is an odd number of sign errors. Now, there's two ways to fix this. One is to fix your error, right? The other is to just make another sign error so that you have an even number of them, and that will flip it back.
Yeah.
Yeah, even number of sign errors. So there are some cases where you can just throw things at it. Another case where I have been known to just throw things at things is the order of matrix operations. So when you multiply matrices by each other, that is not commutative. If you multiply matrix A times matrix B, you get a different result from when you multiply matrix B times matrix A.
Mm-hmm.
And so if you only have two matrices to multiply together, a lot of the time it's like, well, I could think through which one of these is supposed to come first, or I could try both of them.
Yep.
I will admit I have been known to try both of them. The problem is that then you get three matrices, and now you have order ABC, ACB. You start getting more and more as you go on. So you can still kind of just fool with the order of the matrices when you have three, but once you hit four matrices, you actually have to think about it.
Mm-hmm. Yep.
Too many permutations, really. It starts getting unreasonable to try all the permutations.
Right.
So there are things like that. Actually, Brian and I just hit something like this the other day, which is triangle winding order. And so what this is that when you draw graphics on the screen, there's a number of different ways of doing it, but the normal way of drawing graphics is to make everything out of triangles. And when you see a smooth surface, it's just you have enough triangles that it looks smooth. It's a lot of little, and there's some tricks that you do to make it look smooth even when it's kind of faceted, which I won't get into. But a lot of the time your triangles are single-sided. That is to say, if you look at them from one direction, you see them. But if you look at them from the back, you don't see them.
Mm-hmm. Mm-hmm.
Single-sided triangles. And for reasons that I won't get into, the question is which is front and which is back. And it actually has to do with the order that you specify the points of the triangle in, right? From the direction that they're clockwise, you can see it. That's the front. And from the direction that they're counterclockwise, in the order you specified them in, you can't see them. And Brian and I just had to write.
You only see it's just 2 points. You only see 2 points, which makes it.
No, you don't see anything at all.
Oh.
The triangle's invisible from the back.
Mm-hmm.
It doesn't get drawn, basically, if you're looking at it from the back. So this totally works. If you have a totally enclosed thing, if you have a sphere, for instance, right? You can never see the inside of the sphere, right? Let's assume you're never inside the sphere, right?
Mm-hmm.
So there's all these sides of these triangles that you could never possibly see because you're always going to be outside the sphere. So it is a waste of resources for the graphics card. Because remember, the graphics card doesn't just draw the closest thing to you. It draws everything, and the closest thing to you just winds up like being the thing that gets kept. But it does all the drawing. So you don't want to do the extra drawing of the triangles that are occluded, that can't be seen. Right? Because because they're completely occluded. So if you don't draw them, if they're facing away from you, it just saves drawing. It's less drawing for the graphics card.
Interesting.
So, and there were some other reasons. We were doing some stuff involving transparency where we really didn't want the stuff on the other side of the cylinder to be drawn. We only wanted, right? Because in this case, it was cases where you could see it, but we didn't want people to, just because of how we wanted it to look. So we had kind of like forgotten about this and just wrote like a little bit of code to like write a cylinder, right? Which is just like, oh, let's, write something that can define a cylinder in triangles. And the thing is, the cylinder has to be able to change size. It has to be able to change length, and it has to be able to change radius. So again, we're writing a procedure that like, produces cylinders. It takes these as arguments. This is an example of where you have a procedure that takes arguments, and does something sort of generalized, which is that it, we were actually doing something slightly different because of the way things work, but I don't want to try to explain it. So think about it that way, as if we're taking these arguments, radius and diameter, and determining these points. But we wound up with, like, at first we were going to have them be front and back. We didn't realize that we had to only draw, like, the fronts of them at first. And so when we only drew the fronts of them, we were missing about half the triangles from the cylinders. And there were, like, 3 lines of code involved that were producing them, and it was like an error there were two lines of code, really. And it was like an error on one of the lines of code. And it was in a couple of places. And it was sort of like, well, we could think about it, or we could just reverse the order of one of these things and see if we see all the triangles or none of the triangles, right?
Hmm.
And so for the sides of the cylinder, we got it right the first time and we saw all the triangles. But then for the caps of the cylinder, we tried it and we got unlucky and they all disappeared. And we are like, okay, we'll flip it back to the other way.
Yeah.
So sometimes you can just throw stuff at stuff, right? But yeah,
Yeah.
most of the time you actually have to think about things. And
Yeah.
stuff can get really hard. And like there's some cases where it's somebody else's bug, right? You have to work with somebody else's software.
Hmm.
And there's bugs in their implementation. And I'm going to be perfectly honest with you, Maya has a lot of bugs, some of which are pretty show-stopping. And the Maya API is not a friendly environment for developers. It, it's a fairly difficult API to work with. Like even if it had no bugs, it would be a fairly difficult API to work with, and it has quite a few bugs. And so there are times. I mean, Brian and I, so many times working on rig tools, have hit points where you're just like, I don't know if this can be done. And it is this thing where sometimes we spent like a couple of weeks trying to find a workaround for a Maya bug, you know.
Hmm.
And that kind of stuff can be very, very frustrating. And you just have to kind of develop the intestinal fortitude to slog through it because you're like, well, nobody is coming riding to the rescue, right?
Yeah. And there's no
Like,
man to frickin' or I mean, I don't know if there's sometimes stuff you might read that could give you that might trigger an idea or something, or look at someone else's solution to some other problem. But,
yeah, but for a lot of the stuff we're doing, like among other things, we use parts of the Maya API that probably nobody else in the world does,
hmm.
right?
What, yeah.
So, you
What's
know,
API?
application programmers interface. It's sort of what they expose to you, functions that they expose to you that they've written that you can call,
Got it.
right?
Yeah.
So they have an API. They expose a lot of functions to you, and you call those functions to make things from your own code to make things happen in Maya, basically.
Mm-hmm.
And yeah, it's it can be very, I mean, programming can be one of the most intensely frustrating things there is because it's really hard, and sometimes it's just like the other thing is coming up with rig tools, just the algorithms in it. I mean, nobody's ever done this before, right? This is novel algorithms. This was an unsolved problem.
Yeah.
And there's times, boy, there was this one technique called pocket fixing that like I kept coming back to and we just racked our brains. I mean, I think in the end the solution to it wound up being a few hundred lines of code. I would say that in total we probably put 4 or 5 person months into those few hundred lines of code. The
Wow.
number of lines of code that we wrote like attempting to solve this was
Uh-huh.
many thousands of lines of code
Yeah.
that almost all got thrown away. It was just like it was a thing where we didn't know how to solve it. Nobody knew how to solve it, right? It was just like
Yeah.
had never been done before. So
Hmm.
yeah, you get better at that kind of thing,
Right.
at like just being like, well, I'm just going to keep grinding on this. But yeah, I think that would be helpful if you had, something small to do. I don't think we're quite there yet, but when we get to the graphics system, I want to do some, well, actually, even when we get to the recursive stuff, there'll be some things where it's like, well, why don't you try doing this? There'll be some, sort of some interesting little things to do. I also think it might be quite useful for you, by the way. Actually, let me, boy, the lag is going to kill us here. I'm kind of thinking, is there something that I really want to get to before we get off? Or is this, because we're pretty close to done here. And
Yeah.
I just want to see, like, is there something I really want to harp on before we get off? And I think not. I think this is okay. This is not a bad breaking off spot. I would like to point something out to you, though. And the lag is going to be really painful here, but can you pop open a web browser, like preferably Chrome? But if you don't have Chrome, Safari will do.
Foxfire.
Yeah, Foxfire would be preferable to Safari. And like do a Google search for just all one word, SICP. Wow, they have really started loading Firefox up with advertisements, huh? I mean, I'm sure you can
I don't.
hide that stuff, but
Uh, is this still loading? I got structure of
I saw it.
interpretation.
Yeah, so I'm wondering which of the welcome to the SICP website. Or maybe even the third link, Structure and Interpretation of Computer Programs, second edition. That's probably just the book itself.
Oh, this is the one you were talking about. Yeah.
So one thing
Right.
about this is that they have videos online, which you could watch of like MIT classes for freshmen. And some of the stuff in those videos, I suspect, I've never actually watched the videos. I've read the book several times. But let me put it this way. They assume, first of all, that this is your primary priority, which is like working on the stuff in this course. And it's really, it was designed for incoming freshmen, but incoming freshmen to MIT who were computer science majors. So typically they had a fair bit of mathematical background, at least, for people who had just graduated high school, a lot of them had done calculus, I'm sure. And, knew something about programming. They do start from the beginning, but I think it's a hard book to go through on your own if you are trying to learn to program for the first time. However,
Mm.
it does go through some stuff. It would not like if you want to like jump up to like building abstractions with procedures. If you click in the left hand nav panel, there's like a link to it. And so much of this would be, I think, great stuff to read for you. Just kind of read through it. But if you jump forward to where it starts actually showing some code, right? Some of this will look quite familiar to you. Uh, they give some background on John McCarthy and stuff, who was a really interesting guy. So they start off talking about expressions, right? And these just expressions. You've seen this kind of thing.
Yeah.
Um, and they talk about how you can just nest these as deeply as you want. And one thing we haven't, because we've been working so much at the REPL, we haven't talked very much about indentation. Indentation is really important because it is like what allows you to actually read stuff.
Allows you to read it. You said.
Yeah, I mean, you know how like there's a lot of parens and keeping track of the parens is hard.
Yeah.
If you're using a good editor, it will indent things according to the parens. So then you
Hmm.
read it according to the indentation and you ignore the parens. And if the indentation is not what you expect, you're like, okay, my parens are wrong.
Hmm.
Right? Trying to
Interesting.
you don't want to try to keep track of the parens when you're writing complicated stuff. We're just
Yeah.
not writing anything. So they show define, right?
Well, yeah, Oscar Wilde and John Locke in here.
I'm sorry, you're breaking up a little bit. What?
Oh, it might be this rain. I was saying I'm noticing in the footnotes the Oscar Wilde, and they were quoting John Locke at the beginning of the. I just I found that kind of amusing in a computer textbook.
Um, yeah, I don't know. I think you'll find that computer scientists, at least, tend to be a pretty literary bunch.
Yeah.
Alan Perlis, who wrote the foreword to this, wrote a bunch of things called. No, I mean I don't know about wrote, but he has a bunch of things called Perlisisms, which are aphorisms in programming. They're like one-liners, and one of them is Alice in Wonderland is the best book for the layman on the subject of computer science. But that's because Alice in Wonderland is the best book for the layman on any subject.
Hmm.
Anyway,
Cool.
so it's going
I
over
made a
this
note.
in some ways that I think it would be worth reading. If you keep going a little bit, though, I will say it gets to some stuff that actually starts to get right. This is pretty straightforward, and I think some of this might be really, really easy. I can tell you sort of where I think to read to essentially if you do feel like reading this, and where I think you will actually start to bog down, possibly. But you certainly keep going if you want to. So they showed the define syntax before showing lambda. Right, that's a different choice
Hmm.
they made for me. But you'll note that I stole some of Square's directly from them. So the substitution
Oh
model,
yeah.
they talk about this like, um, right. This is what we were talking about tonight, right? Which is like you can see sum of squares, and they've got that body, and they're substituting in these values, right?
Yeah.
That's exactly it. They use slightly different terminology, but to apply a compound procedure to arguments, evaluate the body of the procedure with each formal parameter replaced by the corresponding argument, right? It's exactly the same stuff we were talking about.
Hmm.
And they go through it kind of step by step on paper, which might be kind of nice. I mean, I don't really have a whiteboard to draw on. That we don't have that kind of like back and forth set up properly. So,
Yeah. Right. Yeah.
and your internet's kind of slow, so I taking over your machine I think might be painfully laggy. But
Right.
and it is important to understand this, like that when we talk about this stuff, they're talking about this here. This is to help us think about it. How the
Hmm.
interpreter or the compiler, the implementation actually works may be totally different, right? We don't know and we don't have to care about that. That's
Hmm.
like under the hood. But it helps us
Right.
think
Right.
about it, right?
Yep.
But if you keep going a little bit, just keep.
Oh, okay. Great.
Yeah. So here they're just talking about that thing I was talking about how in scheme the arguments get evaluated, right? Okay, so they bring cond in. This is something we haven't seen. We did see if, but if you wanted to read this should be pretty straightforward, right? We did look at if last time. Cond is a more general form of that. So say just keep going. But if you want to read through cond, that would actually, probably be a good idea. Like they're doing stuff in a somewhat different order than I have, right? So they're showing how to define absolute value. This should be pretty straightforward. We did talk about and, or, and not
Yeah.
last time.
Yeah.
Um, Although you should probably not define greater than or equal because it exists in Racket already. I mean, you go ahead and do it, but
Good.
it does. It didn't exist in MIT scheme, I guess. Um, they keep going, and this is where you may bog down a little bit, though. But feel free to read this. I would say read up to 1.17 if you get a chance, though. This is really interesting, and I think that you have seen all the rules necessary to understand this chapter, but I believe that they're going to introduce some stuff here that's pretty tricky, actually. So, but if you go up to 1.1 point, like, was it 6 or 1.16? Anyway, the stuff before Newton's method, it should all look pretty familiar and be kind of useful.
Cool. Hey, we'll see what happens. Maybe I'll. Yeah. Appreciate
Yeah.
it. Yeah. I think I'll be back.
I'm sorry, you're breaking up a lot again. What?
Yeah, the storm's kicking in. I think I'll probably be back Saturday or Sunday. So.
Okay. Cool.
Man.
Yeah. Well, maybe we'll catch up and talk about non-computer things sometime over the weekend.
Yeah, that'd be cool.
Okay.
Definitely.
All right. Well, it's late. I'm sure you're tired. I'm kind of tired.
Yep.
So
Yep.
I will let you go. And yeah. Yeah. We'll talk this weekend.
All right. Sounds good, man.
All right. Sounds good.
Thanks a
I'll talk
lot.
to you later, man. Thank you. Bye bye.
Bye.